à ce moment-ci.
37. Hello, everyone, and welcome to today's virtual IoT and Edge Days. My name is Serena, and joining us today is our very own Frédéric from the Eclipse Foundation, who will be kicking us off on day one. Without any further delay, Frédéric, over to you.
Thank you very much, Serena, and thank you to the whole Eclipse marketing team for helping us setting up this event. We had great support from Serena and certainly others in the team, and especially Clark Rundy, my dedicated partner in the marketing team. So I thought it would be a good idea before we officially start with the keynote in a few minutes to welcome you, even though this is not formally on the schedule. So you know, when I look at the program for this first day of this year's edition, we really have a number of really exciting presentations in there. Of course, I'm speaking about AI at the edge and Kubernetes right after the keynote, so that will be interesting for sure, given current market trends and all of that, and really. You know, if you can stick around a bit and watch that one, I would be really happy. But we have tons of great content. So right after me, we have Carlos from Zetascale that will bring us from AI at the edge, but you know, with my presentation, but really bring us to microcontrollers and all the little things with Zeno Pico. So Zeno is a homegrown protocol at the Eclipse Foundation. It's really a great project, and Zeno Pico is the tiny version of Zeno targeted at microcontrollers, written in pure C. And really, Carlos is a great all-around guy and a great presenter, and that will be one interesting talk. So that's at 11:45 GMT -4. So that would be 11:45 Eastern time. And then right after lunch, at least for those of you who are in Eastern time, we'll have a talk by Mark Poos about an open source lamp-like stack for IoT and embedded. And really, I like the idea of those stacks in the sense that it's one thing to have building blocks, but to have some of them that have been, you know, pre-configured, working together, that's really a great developer productivity aid. And certainly the main stack that Mark will present is one of those. Then in the afternoon, later, Eastern time once again, maybe at night if you are in Europe, or really, really late if you are in India and other places in the world, we'll have 5 easy steps for more secure IoT talk by a new colleague that we have at the Eclipse Foundation, Marta. And that really highlights something interesting that's happening at Eclipse, in the sense that we are increasingly concerned with the secure software bill of materials and innovations like that, to make sure that our components at Eclipse are really not only validated from an IP perspective, like we were doing in the past, we continue to do that increasingly with automation, but really to make sure that everything in there is traceable and that we keep our dependencies current and all of that. And hiring Marta and growing our security team is part of those efforts. So certainly I'm looking forward to our talk later in the day. And we close the first day with a talk by Wes Johnson, the project lead and the lead of the Sparkplug specification committee. So really going beyond MQTT with Sparkplug. So MQTT, of course, is a great protocol. MQTT is something that many of us on this broadcast are probably leveraging already. But in any case, Sparkplug brings MQTT to the next level, and Wes will tell us why. And one interesting tidbit about MQTT that I'd like to share with you is that many of you already know that we submitted in November of last year Sparkplug for transposition as an international ISO IEC standard, at ISO IEC GTC1. And essentially, this is a multi-month process getting there, but what happened a few days ago is that the ballot period where national bodies were able to vote on making Sparkplug an international standard closed. It was a 12-week ballot starting in February. It closed on May 3, and we have been notified that the vote has been successful. So now some delegations or some national bodies made comments that we need to address and things like that. It will take some more time, but in a few months, Sparkplug will officially be known as ISO IEC 20237. I know it rolls off the tongue, but in any case, it's a great accomplishment. So congrats to the Sparkplug community on this achievement of making it an international standard. And of course, you will hear more from the Eclipse Foundation as we get closer to the official publication of all of that. So in any case, that's all I have for now. I need to get prepared, first to listen to Mike's keynote, and after that, get prepared to my own talk. But in any case, thank you so much for being here today. Really appreciate your presence. And don't hesitate to let us know if there's anything we can improve about this event. Of course, this is not the first time we're doing this, and with the support of professionals like Serena, most things will go the best way possible. But if you have good things or bad things to say, please share your feedback with us so that we can make the 2024 edition of this event even better. And in the meantime, while you're waiting for Mike, please take the IoT and Edge developer and adoption surveys. You have the link at the bottom of the screen. This big, large, green, shiny button with an animation there. You click on that to get to the survey. And this is really an important survey because everything we do, we publish under a Creative Commons license. We share back with the community. So help the open source community know what are the current trends in IoT and Edge by taking the survey. So in any case, thank you, everyone. Thank you, Serena. And have a fantastic first day of virtual IoT and Edge Days.
Thank you so much, Frédéric. So we will be back in about 8 minutes. In the interim, I'll post up the agenda slides so you guys can see, again, what is waiting for us throughout the day. Thank you all so much, and see you very soon. Welcome back, everyone. And joining us now is Mike for his talk on Open Source One now. Open Source One, now comes the hard part. Mike, over to you.
Thank you so much. Let me just share my screen. And slideshow. And hopefully, can everybody see my screen? Serena, can you see my screen?
100%. Yep, everything
Alrighty.
looks great.
So thank you, everybody. It's my pleasure to be here. For those who don't know me, I'm Mike Milinkovich, the Executive Director of the Eclipse Foundation. My talk today is about some upcoming changes that are going to be industry-wide and worldwide with regards to how open source is going to be, well, actually, how the software industry is going to be regulated and how open source could be affected by that. So when I say that open source one, what do I mean? And I could do 20 minutes on this topic alone, but basically what we're saying is that in today's applications, when you look into them, and for a lot of products, 80 to 90% of the code that's in there is open source. So open source has become absolutely mainstream, and even companies as large and as conservative as 100-year-old Mercedes-Benz is recognizing that open source is the way that software gets built today. But of course, we're all aware that there's been some open source, pretty famous open source security issues. I think one of the first ones that really put open source on the radar in terms of how ubiquitous it had become was the Heartbleed bug in OpenSSL in 2014. It's amazing to think that that's 9 years ago now. But it really helped educate the market, the industry, if you will, that open source has become critical infrastructure. But it was also, OpenSSL was security related. So it kind of made sense that, there's a security problem. It would come from an open source component that is directly security related. But then 2 years ago now, in late 2021, there was the Log4j, Apache Log4j bug that was dubbed Log4Shell. And that was a really different phenomenon in terms of raising awareness of the issues around security and open source, because nobody expected that a Java logging framework was going to be the source of a critical infrastructure problem and a critical security problem. And so one of the things that a lot of people came away concluding from the whole Log4Shell experience was that open source had become completely ubiquitous. It was literally everywhere. And any one of these pieces of code could become a vector for a security vulnerability. And that was really a moment that I think an inflection point in terms of the realization of how important open source had become and how important securing open source has become. Because in parallel to the ever increasing use of open source, another thing that has to be kept in mind is that cybersecurity is becoming a very expensive issue, because cybercrime is now the world's third largest economy. And what that is, if you went after the US and China, there's more money being made in cybercrime than any of the other economies out there. And it's projected that by 2025, there's going to be $10.5 trillion in damages on a worldwide basis. And supply chain attacks are a huge part of this. And supply chain hacks have really increased over the last couple of years, to the point where we're looking, 742% year over year in terms of increases. But what is this thing that we call a software supply chain? And we're all developers. We're all familiar with this. Basically, you build some source code, you write some source code, then you build it. Of course, you've got dependencies, and there's every piece of open source code is relying on other pieces of open source code. Nobody nobody builds software anymore without relying upon other components. And then, of course, that's packaged up and delivered to the end consumer. And of course, dependencies are just one source of attack, but you can have points of attack every single place along the way. The issue is that this, of course, is all recursive. So as you go down through your dependencies, you've got potential attacks both in your own code and how you're managing your own infrastructure. Each one of these points could be a potential source of a supply chain hack. And then once you bundle in the fact that it's recursive and your pipeline goes, down, and it's, basically turtles all the way down, you find tons and tons of dependencies, and any one of these could potentially be a source of a problem throughout the supply chain. And so it's a really deep and recursive problem in order of managing the supply chain for software, because of how ubiquitous open source has become, and how deep these dependencies can get nested. Now, if we have a supply chain, who maintains the supply chain? And of course, everybody who is part of software development has seen this XKCD comic that talks about the fact that there's huge stacks of software that are being built and consumed around the world, and that it all relies upon one lonely person in Nebraska who's keeping the whole thing going. But I hate to say this, but it's actually way worse than that. So this is a chart that was from a blog related to the Open Source Security Podcast. So if you Google Open Source Security Podcast, you'll find these guys. Highly entertaining, highly recommended if you're interested. And they blogged about, and they've done this analysis is on NPM, but they've repeated this with Linux package dependencies and others. But what they keep finding, no matter where they look, is that the average project team size for, in this case, NPM, is extremely small. Basically, it's a Pareto curve on steroids, and most packages are maintained. The vast majority of packages are maintained by one person. And of course, you're going to say, well, that's NPM, but surely that's a huge community. If you look at you're looking at the long tail. What about the top 5% most important packages on NPM? And as you can see, the graph hardly changes at all. So we really do have this issue where the project teams that we depend upon, whether you're talking about NPM and Linux, one of the examples they talk about is the AutoConf package in Linux has not had a single maintainer since 2012. So critical, important pieces of our supply chain and our digital infrastructure are being maintained by incredibly small teams, and this pattern is being repeated all the way through the open source ecosystem. And we see this in Eclipse too. Like, there's lots of packages on Eclipse Marketplace that are maintained by one person, and we have more than a few projects at the Eclipse Foundation itself where we see very, very small teams, particularly if you focus on the most active people that are working on the projects. So we've come to this conclusion where, if you're looking at it from a government policy perspective, open source is everywhere. Open source is critical, and open source has been shown to cause harm to consumers and impacting businesses. And of course, open source has been completely unregulated and unmanaged from a government perspective throughout its entire history. And so, whenever you present governments around the world with problems, they have solutions, and so that is really the crux of the issue here. That we are now getting into a scenario where government policy is going to start to impact not just how the open source community, but more broadly than that, the entire software industry has been unregulated throughout its history, and is about to become a regulated industry. And so in the US, you've got the National Cybersecurity Strategy. You've got the Biden executive order on improving the cybersecurity. The act to establish the CISA agency within the U.S. government, and then in Europe we've got the Cyber Resilience Act, which we'll be talking about at some length as we go through this. Now, the National Cybersecurity Strategy in the U.S. The tact that they're taking seems to be focusing on amending liability law to make it clear that producers of defective software are going to be held liable for the problems that their software causes. That's at the heart of the National Cybersecurity Strategy. But what they've done stated in the strategy is that the developers of open source components are not going to be the ones that are going to be on the hook. It's really going to be the companies or entities that commercialize the software that are going to bear the burden of liability. And I think that on balance, certainly from an open source perspective, I think is striking the right balance, because as we saw, there's a great deal of the digital infrastructure that we rely upon are maintained by very, very small teams, and they frankly simply don't have the financial, legal, or even technical resources to dramatically improve their security posture. Now, but let's turn now to Europe and the Cyber Resilience Act, because fundamentally the Cyber Resilience Act is a very, very different beast, and in particular is not going to be carving out, as it is currently drafted and proposed, does not have an adequate carve out for open source at all. And in fact, I've spoken personally with the authors of the Cyber Resilience Act, and they're very clear that, in their opinion, open source software, open source components are intended to be regulated by the Cyber Resilience Act. And fundamentally, what is the intent of the Cyber Resilience Act? And the intent is to apply the CE mark regulatory regime to all software. Now, the original remit for the Commission to devise the Cyber Resilience Act was to focus on IoT consumer devices, but somewhere along the way, they decided that they wanted to include all software. So this is actually the first time in European history where the definition of products is being extended to include purely intangible products like software, for both the CRA and also for a related a related law called the Product Liability Directive. But the CE mark regime, and this is IoT and edge compute, so I'm sure there's people here that have dealt with this in the past, is applying a process for doing secure software development, which is going to apply to all software products made available in the European market. Now, what are we talking about here in terms of the kinds of processes? And so one of the things to make it clear is that this is a very much a waterfall model that is being basically enshrined in law. So what you're going to have to do for every product being made available in Europe is to fully document the development, release, and maintenance processes for each. And in our case, I'm focusing on open source. This is true of products, but in our case, for each project in accordance with the CRA. And there's annexes to the CRA that detail pages of individual process requirements that each project is going to have to comply with. And then for each release of the project, you're going to have to certify that the project conforms to the processes that you've documented, and legally attest to that conformance. So an officer of the organization needs to sign a document saying that the project has delivered on the process. And then for projects which are critical or highly critical, things like operating systems, SCADA systems, industrial control systems, user authentication and management systems, there's going to be an additional requirement to hire external auditors to ensure that your processes are in compliance with the CRA. And obviously that's going to dramatically increase the time and the expense required to do product releases and project releases from open source communities. And as I mentioned before, this is a waterfall kind of model, and you have to do this work for each release of the software. So obviously, we're talking about a very significant increase in the amount of work that's going to go into doing software releases. And who does this apply to? This applies to any entity making software available on the European single market. So it's obviously very broad, because it's not just about being a European company. You know, if your software is downloadable from Europe, then you have to deal with this. So it pretty much applies to all providers of software, and it provides also online marketplaces and repositories. Think Eclipse Marketplace, but also think Maven Central, NPM, PyPy, and the like. So potential consequences. So this is going to make a reasonable and rational, conclusion is, don't make your software available in Europe. And so that's one potential outcome, unintended consequences. Of course, European companies, I think, are going to be at a disadvantage, and European open source communities potentially at a disadvantage, because there's really no way to avoid complying with the requirements. There's also a possibility that the package distribution sites that are so central to producing open source software might refuse to accept responsibility. And this has already been publicly mused about by Brian Fox from Maven Central. And finally, there's a concern that open source companies might stop contributing to open source projects, because right now they don't understand the risk profile. And hopefully we have a couple of years to figure this out. But it definitely has a potential to damage the innovation economy in Europe. Just as we're really convincing European companies that open source is the way to collaborate on innovation, then we're suddenly going to be tapping the brakes via the CRA. So I guess fundamentally the final question is this bad? From my own personal opinion, I think that the software industry has become so important to our economies and societies that some form of regulation is probably appropriate. But I think that the CRA definitely represents an over-regulation that is going to harm the digital and innovation economies in Europe in unforeseen ways. This is so complicated, and it's so overreaching, for lack of a better word. I don't think anybody can really foresee all of the implications that are going to come from the CRA, other than to say that this is going to be one heck of a shock to the system, going from an unregulated industry to an industry which is effectively related as a hazardous product in a few short years. And with that, I thank you, and I think I've used up my allotted time. Do we have any time for questions, Serena?
We certainly do. So I would encourage, thank you so much, Mike, for that great presentation and quick summary, and condensing that presentation in 20 minutes. Everyone, I encourage you to use the Ask a Questions tab, or ask any questions that you may have in the chat. We are here ready for you. I'll give you a couple of moments, and I'll take this opportunity again to highlight our wonderful survey to get all of your input from the community. So we have Matthias. We at Cantina X have big quality gates that cover that process. Is hard for a developer, but if there is legal responsible, is not impossible.
Yes, Cantina X represents a particular industry initiative that has a lot of developers working on it. I would venture to say that there are literally millions of packages on NPM, on Linux, on Maven Central, on Python, that do not have the resources of something like Cantina X. And so just because I want to caution against any sense of complacency that, okay, well, my project's okay, so that means open source is okay, because I quite firmly believe that that's actually not the case.
Okay. And we do have another question. So is there a chance we can improve the CRA at this point, and what can we do? And this is from Frédéric.
Thank you. So yes, the sad part is we are now in the realm of politics. And what I mean by that is the time where we can influence the commission to amend the drafts is now gone. It was gone basically when they published the first draft back in their draft back in October. So the only way that we can influence the outcome now is working through the European Parliament committees that are suggesting amendments, and working through the country delegations at the European Council. And so basically trying to influence or lobby these entities to find changes that will do less harm to open source. But I want to reiterate, for those that are watching, my focus, of course, is on open source. That's my job. That's what I do. But just from the perspective of the software industry as a whole, going from a completely unregulated industry to a highly regulated industry in a few short years is going to be a dramatic shock to the entire industry. And open source, of course, being part of that.
Okay, amazing. Thank you for that. So that concludes Mike's session. There's no more questions, and we will be back at 10:45 in just about 7 minutes with Frédéric. Thank you again so much, Mike.
Thank you.
Welcome back, Frédéric, and welcome everyone. Frédéric will be speaking about, does AI need Kubernetes at the edge? Frédéric, over to you.
Thank you so much. And thank you everyone for being here. Hopefully following Mike's keynote, I will end up on a higher note or less depressing conclusion, we'll see. In any case, about me, if you don't know me, I'm the program manager for IoT and Edge Computing at the Eclipse Foundation. I've been around in the industry for a while now, most recent jobs around, mobile and containers and things like that at Oracle, Pivotal, Cisco, where I started to do deep dives into IoT. I'm a published author and frequent speaker, and you can find me on Twitter, at least for the time being, who knows, and LinkedIn. Now, one thing I'd like to remind you is that I have a little book to sell. So if you are curious about the whole ecosystem of Eclipse IoT and edge computing components, well, this is a book for you. This is really a comprehensive review of what we have available. And really, I wrote the book, but our committers and open source contributors did the hard work of building all of those projects. So, you can have a look at the book, of course, but please use the great projects that they are working on at the Eclipse Foundation. All right. Now, the topic of this talk is a question. Does AI need Kubernetes at the edge? And really, my goal today is to give you the definitive answer to that question. Okay? So right now, I will unveil to you. So if you need to go elsewhere, you can leave the broadcast knowing that you have the definitive answer to this question. Okay? And the definitive answer is maybe. So really, the whole point of the talk is to have a look at what we are doing at the edge, why we would need Kubernetes, and look at specific use cases from industrial automation and automotive to try to understand a bit whether we need Kubernetes or not when we are doing AI at the edge. Okay. So sorry, you won't get a real definitive answer, but as in many things in IT, the answer depends on the specific circumstances of your project, of course. So there's no way I would be coming with a pure yes or a pure no, because there are so many variables to take into account. So this is a bit like weather in some way. Okay, so the way I structured presentation is that first we'll take a step back and look at what we are talking about when we talk about edge and what kind of things we are running at the edge when we do AI. Then we'll have a broader look at the type of workloads that edge computing can tackle. And AI is one of them, but there are several others. And really in picking the right platform, the right framework, I think it's important to be mindful of those other workloads in the sense that AI is great, but at the same time, if you paint yourself, into a corner with an AI specific framework, then maybe you won't be able to do other types of projects. So anyway, being mindful of the whole spectrum of workloads is really important. Then we'll focus specifically on Kubernetes and the ways you can deploy that at the edge and whether that's a good fit for AI or not. And finally, I will conclude with a short overview of our vision for edge computing at the Eclipse Foundation, EdgeOps. And EdgeOps is, when I say our vision, I mean, this is the vision of our open source contributors, our project leads, our project committers. That's not about me, but really what our community thinks. So in any case, don't hesitate if you have questions as we go forward. You can use the Ask a Question button on the UI to ask questions there. And we will tackle them at the end of the presentation. So thank you for your patience. All right, so we cannot talk about edge computing without defining what the cloud is, because essentially edge is not the cloud. So it's easier to define edge when we are mindful of what cloud is and what cloud native is. And really the cloud is an environment with on-demand availability of resources. You want to create 1,000 VMs, in theory you can. Now, I have a friend from a previous job, that completely exhausted a specific type of instance on this cloud provider in a specific geographic location. Okay, so although it's on-demand availability of resources, the cloud may have some higher, higher thresholds that you cannot cross at some points if you are really, really ambitious about your deployments and wish to pay incredible invoices at the end of the month. But anyway, the cloud environment is really about, I need something, I can demand it to be provisioned, and I get it after a few seconds or a few minutes in the worst cases. And the cloud is about homogeneity, large scale, and centralization. Really, when I request a specific instance type on my cloud provider, I know what kind of resources I will get, even though I could, of course, customize the instance type and add additional resources. Then, of course, everything is at a very large scale, not infinite, but very large scale. And it's centralized. I have this handy dandy console that I can connect to. And then from that central location, I can control everything that I have, even though I'm going through or coordinating resources across availability zones or other mechanisms like that to ensure availability in specific geographical locations. In any case, this is what the cloud is about, and really it's great. The only problem is that, of course, the edge is completely different. So the edge is a place, so to speak, and a physical place where resources are distributed anywhere and everywhere, until the very limit of the cloud. And this is really important to understand that because, even though we have availability zones and things that are somehow related to geography in cloud native applications and in the cloud itself, you don't care so much whether, the actual servers, if you pick the European geography for your instances, you don't care so much that they would be, let's say, in Berlin versus Paris versus any other place in Europe. If your intent is to have those instances in Europe, probably that's good enough. In the case of Edge, the thing is you are placing nodes in the real world in very specific locations, and you care very much whether they are on this side of the street or the other side of the street, because this could have an effect on the latency of your solution, for example. So really, Edge is the polar opposite of cloud in the sense that it's completely distributed, it's operating at a small scale, and it's heterogeneous. And when I say small scale, it's not that you cannot deploy thousands of edge nodes. You can, but each of those nodes has typically very limited resources. So this is not the kind of elasticity you get in the cloud. And of course, the nodes are heterogeneous because you are trying to optimize power consumption for specific use cases. So you will pick the specific microcontroller or the specific gateway that is the most well suited for the job. And sometimes then you will plug in AI accelerators and things like that in order to make specific workloads run better in that type of environment, which means that you have to deal with several architectures like ARM and RISC-V increasingly that you wouldn't necessarily easily find in the cloud, although ARM availability in the cloud is improving a bit. But in any case, the one thing to remember is that the edge is really not like the cloud. And that's the whole point. You're trying to get outside the cloud in the real world to be closer to the source of your data. And from a more structured perspective, really, we have a little more structured definition of edge computing there. And this is really about compute, networking, and storage closer to the action at the border of the network. And really, in some cases, you will even maintain the elasticity and consumption-based pricing model of the cloud, but not always. And of course, if you're trying to improve on power consumption, or if you talk about battery-operated devices, then your elasticity will be very small or even non-existent. Now, we have covered cloud versus edge. What about cloud native versus edge native? And really, cloud native is about a few things. I put a few of those on the screen, and maybe your own personal definition is a bit different. In any case, cloud native is about DevOps, really this approach where we don't necessarily merge the teams, but we have developers and operations working together to ensure that applications are available, that they work well, that they are properly monitored, and of course that we deploy new versions together. This is about a set of agile methodologies, plural, and your mileage may vary there, but most DevOps or cloud-native organizations today are doing agile in one form or another. And of course, from a technical standpoint, we're talking about microservices, container orchestration, and my pivotal past is showing up a bit here. So repair, repave, rotate. Essentially, no specific container is really important as long as the application is running. So if you have a container instance that's misbehaving, then you delete it and you deploy it anew. And of course, rotating those containers frequently reduces the probability that you may have exploits in the wild. And that's, in most organizations, some things that people will do just on from a security standpoint. Now, edge computing has specific strengths, specific things that you want to use it for. And there are many, many of those challenges that edge computing helps you with. So I just put the 4 main ones on this particular slide. Of course, since you are deploying edge nodes closer to the action, so to speak, in the real world, then edge computing is really useful to reduce latency. Of course, since you are doing local processing instead of sending everything in real time to the cloud, edge computing is also useful to reduce bandwidth consumption. Edge computing is probably the ultimate form of distributed computing, which means that typically well-architectured edge computing solutions will be more resilient. So resiliency is certainly one of the things it provides, granted that it's implemented in the correct way. And finally, data sovereignty is a fantastic benefit from edge computing, because essentially, if you care that patient data will not leave this particular hospital, if you care that data about financial transactions will stay inside the European Union or inside the US, okay, from a physical standpoint, then with edge computing, you can guarantee those things because you have specific edge nodes in specific locations, and the data can stay on those nodes if it's not supposed to leave a specific geographical location, okay? And all of that, showcases the tremendous value that you have in putting an edge node between your constrained devices, at the very, very extreme end, and the cloud on the other end. Those two things always exist, and it is my contention that going forward, most, if not all, IoT deployments in the wild will have some level of edge computing in the middle because there are so many benefits to it. Now, what makes edge native different, let's say, from cloud native? Well, first is the assumption that the network will degrade at any time, at any random time, and fail at some point, okay? And you need to bake that into your infrastructure and into your applications as well. But of course, adapting your applications to an environment like that is much easier when you have a platform that supports you in doing so. Then, they say that premature optimization is the root of all evils in IT. But in the case of edge computing, you need to optimize for size and power really early into the process. And the reason for this is not simply that you have a very constrained edge node that you want to ensure that it won't sip too much battery power. I mean, those are important considerations. But if you take over the long term, okay, optimizing for size and power is also important from a durability standpoint, from the fact, from the standpoint that you want this edge computing solution or this enterprise IoT solution to be very durable, so that you're not replacing edge nodes every year or every 2 years or something like that. You're deploying hardware and software, for the next 5-10 years or more. And this means, if you optimize early for size and power, you ensure that your edge nodes will be right-sized for the whole lifetime of the solution. And in the same way, you will reduce hardware failures if you reduce power consumption, because the more power you consume, the beefier cooling you need. And cooling is one of the weak links in IT. And if your cooling fails, then the rest of the hardware will fail in order as well and will be less durable. So optimizing for size and power is really the smart thing to do in Edge, because essentially, if you don't do that, you may compromise, the durability of your solution. And of course, zero trust is an especially important aspect of edge computing. You don't want to trust those edge nodes because they are in the wild and anyone could, pick one, hack it, and then send data, manipulated data in order to influence your organization's decisions, for example. And that's the easy case. I mean, of course, they could use it as a vector for other sorts of attacks on the rest of the IT infrastructure that you have. So, of course, zero trust is, central to everything that we do in edge computing. Now, if we take the AI perspective, what will we do typically at the edge from an AI perspective? Of course, model training is a possibility. I mean, typically, especially with, the beefier models, training will happen in the cloud because you need vast quantities of data in order to train the model. But you could, from a technical standpoint, perform it at the edge, whether it's in a regional or local edge data center. Those are increasingly available. So you could perform part of the training or even the whole training of your model there if it's small enough to fit into the resources that you have in those local data centers. And of course, if you have very smaller applications and very focused one, it could be possible to train a full model on an edge node or set of edge nodes, for example. Although this is less common because, the more data you have, the better the model will be. So certainly, the cloud plays an important role there, but depending on your specific AI solution, then of course, part of even the whole training could happen at the edge. Then, of course, what you will certainly do if you do AI is to run your model. Essentially, your inference engines can run on constrained devices and even microcontrollers. TinyML is a whole field, a fascinating field of AI right now, really an exciting one. And if you're not doing it, I invite you to do so, because you can do tremendous things with a handful of megahertz and a handful of kilobytes even in the most extreme cases. And really, if for whatever reason you are using a very constrained device and you want to be more power efficient, there's a whole range of AI accelerators that are available, whether on chip. So several microcontrollers now include circuitry that's really dedicated to AI, or even as peripherals to USB buses or PCI bus in the case of more elaborate solutions. Anyway, all of that to say is that certainly in the case of AI at the edge, you will run tons of inference engines, and you will have to take into account, the potential heterogeneity of the AI accelerators that you will deploy in order to shoulder the workloads in a more efficient way. And then, of course, you will to train and retrain your model at some point. So the data that you gather at the edge will be critical to the retraining. Of course, if you do the training at the edge, then maybe you will re-inject it right away. And if not, then you need to send that very, very precious data, to the cloud or to an edge data center in order to retrain the model and then get back an updated model to run. And this highlights that in the case of AI at the edge, having a proper over-the-air update solution is really, really important, because you will shuffle models around, you will shuffle data around as well. So having reliable networking, having reliable ways to update those edge nodes that you will deploy and those constrained devices that would be running models and things like that is especially important. So please have a look at Eclipse Hogbit. That's certainly one very generic project that you can leverage in order to deploy all sorts of artifacts, not only on powerful edge nodes or edge data centers, but you can go all the way to microcontrollers as well. Now, let's have a broader look at other types of edge computing workloads, and we'll discuss a bit, again, the specificities of AI workloads as well. So first thing to remember is that the edge to cloud is a continuum, okay? So lots of people will have very specific categorization, tell you there are 2 edges, there are 3 edges, carrier edge, network edge, and things like that. Well, I think that's the wrong way to think about this, because essentially, as long as you are outside the cloud or the corporate data center, okay, you are at the edge, somewhere at the edge. And applications and their components will be distributed all the way from the very, very constrained device on one hand, all the way up to the cloud at the other end. And you need, in picking frameworks and tools and platforms, solutions that will adapt to those very different environments in a secure and flexible way, okay? That's really an important consideration. Now, of course, we have 3 distinct planes that will see their components deployed all over the place. The data plane, the control plane, the management plane. And once again, all of those things, are interdependent. And at the same time, all of those things may have components all, over the place in the edge to cloud continuum, okay? And if you have a platform that is not flexible enough, then you will maybe run into specific problems. In any case, the data plane is really focused on your applications. That's the software components that you are deploying. The control plane, of course, control the applications in the infrastructure and does the real-time monitoring. The management plane will address application or infrastructure management and device considerations. And of course, there will be AI in your data plane in the applications that you deploy, but there may be, and there is increasingly AI in the other 2 planes, because we see emerging models where you will see AI-driven auto-tuning of edge nodes, for example, or things like that. So you may be both an AI user in the case of the control and management planes, and an AI deployer, so to speak, if you do AI at the edge on the data plane. Now, we run developer and adoption surveys for IoT and Edge every year at the Eclipse Foundation since, I think, 2015. And in the latest published edition of our developer survey, we found out that AI is the top workload at the edge, and we saw that it grew from 21% in 2021 to 38%, nearly double in the 2022 edition. But there are many other types of workloads as well, and what we see in those numbers is that control logic, data exchange, data analytics all grew along with AI as well. So being interested in AI is all and well, and certainly it's the right thing to do. But, and that's an important consideration, I would remind you that there are other types of workloads and that you need in picking an edge platform, something that will help you to address all of those types of workloads in a proper way, not just one, that's tightly focused on AI, because, others are finding that they need to run multiple types of workloads, and you will find it as well at some point. And in any case, that's the 22 edition of the survey. So to participate in the 2023 edition, which is open right now, you can use the button under the slides and under my face. There's this big green large button there that you can click on to take the survey right away. Well, don't do that right away. Let me finish my presentation. But in the pause between the talks, maybe you can use that time to take the survey. And thank you in advance if you do so. So from a technical standpoint, what we found out is that container orchestration at the edge is really, really important, but VM images, native binaries, and even script files are also used a lot. And once again, if you have a platform that does just container, then okay, fine. You can probably find ways to run native binaries and script files in a different way. But anyway, the best platforms will help you to tackle all of those types of artifacts in various ways. And of course, containers are important, but they are not the only consideration. And this brings us back a bit to the Kubernetes discussion, in the sense that, of course, Kubernetes is about containers, but it's, at the edge, a wider word than just containers. So you will probably need to look at something else in order to do VMs or script files, depending on what your intent is. And of course, keep an eye on WebAssembly, because we certainly see lots of exciting innovations in that space and lots of growth in edge use of WebAssembly recently. So what makes edge AI different from, let's say, cloud AI or AI that you would be doing on your desktop or laptop on your desk? And really, there are three important things to take into account. First, if you are running an inference engine, then of course the decision process will only involve a fragment of the whole data set. You are on this edge node, it's maybe isolated from others. It wouldn't necessarily make sense to interconnect all of those nodes to exchange all of the data, because you are processing part of it and making AI-driven decisions on that particular node. And most good models will be able to correct a bit the effects of having just part of the full data set available locally, but you will probably need to do some trial and error before you discover the threshold of let's say the threshold over which your decisions will become a bit bad or not as good as they could be, because you are operating on a fragment of the whole data set. Of course, then if you are asking for outside help, because sometimes there are anomalies on the data and things like that, well, the network won't necessarily be always available all the time, which means essentially this error function sometimes won't be able to call out to the cloud or to a remote data center and ask for outside help in order to process specific data or make specific decisions. So you need to design your whole system around this fact, because if you have a time-sensitive critical decision to make, there are data anomalies, and then you cannot execute properly your error function, then of course you could kill someone, for example, if we're talking about an autonomous driven vehicle, for example. So really, you need, once again, to go back to the fact that the network will go out or degrade at any given time, and design the whole solution accordingly. And of course, optimization of your model and the decisions that you are making will be influenced by local conditions. And of course, once again, the best models are able to smoothen anomalies that would be influenced by variations in local conditions. But sometimes, they may be very, very local and then taint a bit the data sent by specific nodes. For example, if I'm measuring air quality and my node is placed in a specific spot in a warehouse where condensation is forming due to various architectural considerations, then the air there will be more humid for whatever reason than in the rest of the warehouse, and you will make decisions according to that. So it's really important to remember once again that your edge nodes where you're doing those AI-driven decisions are in specific physical spots, and those specific spots in the real world are influenced by very local conditions that you need to take into account into your models. Now, let's do a short deep dive into the Kubernetes ecosystem and how you could deploy Kubernetes at the edge. So, this particular slide is not exhaustive in the sense that what I'm trying to do here is to show various ways and various architectures that are used at the edge in order to deploy Kubernetes. And what you see on the left of the slide is just a comparison point. This is the full-fat Kubernetes as you would find in any cloud implementation or even platform as a service implementation that you can subscribe to in the cloud. And as you can see, lots of components, lots of flexibility as well, of course, since Kubernetes is a fantastic way to orchestrate stateless workloads in the cloud. Now, what we see in the middle and on the right are two different ways that specific open source projects have used in order to slim down Kubernetes and make it a bit more adapted to the edge environment. So the first one is K3S, which is a CNCF project. And really, the KTS approach is to squish all of the separate components in a Kubernetes installation in a single binary. Okay, so you still have your metrics server, network and load balancing, and things like that, like you would find in a typical full-fat Kubernetes environment. But all of the K3S components, along with the metrics server and networking and load balancing, are condensed into a single binary. And here, the etcd database is replaced with an embedded SQLite database. And essentially, that makes the whole solution more resilient to power outages or any other weird situation that could happen at the edge. Okay, but from a code standpoint, K3S is only 1,000. The delta between the mainline Kubernetes code and the K3S code is a handful of thousands of lines of difference. So that's not a huge difference between the two code bases. So this is really close to mainline Kubernetes. And of course, since it's slimmed down a lot, you can deploy it on very constrained nodes at the edge. Then we have the KubeEdge project, which is another CNCF project. And KubeEdge is taking a different approach from K3S. So K3S is making the mainline Kubernetes code more adapted to the edge environment. And KubeEdge picked a different route in the sense that what they are aiming for is API compatibility with custom components, what you see here, Cloud Core, Edge Hub, and things like that. So essentially, they wrote edge-optimized components in order to run Kubernetes workloads at the edge. And then they have full compatibility with the API server. Okay, and essentially, this is a different approach, not necessarily better or worse than K3S, but this is one of the ways that people have slimmed down Kubernetes to use it at the edge. Okay, but there's a whole wide world of other solutions that you can find, and some of them, of course, live at the Eclipse Foundation. You have Eclipse Fog05, Eclipse IoFog, Eclipse Kento, Eclipse Kura that I will tell you a bit about, and others. And some of them are literally Kubernetes. Some of them integrate with it. So I would tell you, if you are interested in running container workloads or even Kubernetes workloads at the edge, well, having a broader look at the set of open source alternatives, not just at Eclipse, but including at the Eclipse Foundation, would be a good idea, because there are so many interesting projects that are doing great things. And some of them can be deployed, in what we say isolated or standalone mode at the edge only, with no connection to the cloud. And that's really useful in a wide variety of scenarios. If you're working in defense, if you're working in healthcare and other regulated environments, for example, to have an air-gapped environment that's completely disconnected from the internet is a good thing to do sometimes. And some of those orchestration solutions that you see on the slide are certainly capable to do that. Now let's take a use case driven approach to think about whether we should run Kubernetes or not at the edge. And here I'm discussing automotive, and after that, a bit of industrial automation. So of course, the modern car, when you consider it, is a data center. There are plenty of sensors, little computers and microcontrollers all over the place, and even bigger ones to run the infotainment and things like that. So should I run Kubernetes in my modern connected car? Okay. And there, well, I think part of the answer comes from the use cases themselves. When you look at the most recent and most innovative cars in the market right now, you will see features, okay, really that will be around vehicle management, predictive maintenance, commerce, safety, driver assistance, and things like that, okay? And many of those features right now are AI-driven or will become increasingly AI-driven in the upcoming years, okay? Now, it's one thing if my infotainment system is running on Kubernetes and the container gets deleted and restarted at some point for load management reasons. Okay, maybe I will lose the sound or other infotainment features for a few seconds, no big deal. The same goes for predictive maintenance. Whether I know right now or in 10 seconds when the container restarts that I need an oil change in 1 month, okay, won't make a big difference. And I could imagine a workload like that being deployed in Kubernetes without any problem. However, driver assistance, safety, those workloads are mission critical in the sense that if they fail, then literally I could be, as a driver, killed, or I could kill someone in another car or even a pedestrian. And we don't want that to happen. Then the problem is, of course, that Kubernetes is not necessarily the best environment to run real-time types of applications or applications that have mission-critical requirements, okay, where we need guaranteed latency and things like that, for which an environment with a real-time operating system is really required, right? The ABS brakes in your car are a good example of that. That's a critical subsystem of your car, and the microcontrollers that are driving that are really they really need to make decisions in a specific time frame to ensure that you don't die. Okay, so the answer whether you should use Kubernetes in the connected car or not is it depends whether you are running any mission critical AI or not. So the modern factory, like the modern car, is a data center as well. Plenty of compute and network and storage all over the place. So should you run Kubernetes in a modern factory? And of course, it depends again about which layer we are talking about. So this handy-dandy diagram comes from the documentation from the Eclipse Basics project, where they illustrate the various layers that the Basics system can address. And you see that there are field-level components. That's literally your robot that's welding the frame of your next connected car. Device level, middleware, and then at the top level, plant level types of system like the SCADA systems that are driving all of those industrial processes. And of course, if we talk about the SCADA system itself and AI that's, let's say, monitoring the air quality in the factory and things like that, I could see things like that being run in containers in a Kubernetes environment. But no way you will deploy Kubernetes on the robot that's doing precision welds, where if there is a tiny bit of additional latency, then the whole weld will be ruined and the car frame will be thrown away at the end of the process. So you have to remember that the factory is really an environment where there are risks, of course, to human life and things like that, but also an environment where, producing as much as possible, with the required quality levels is the mission of the whole thing. Okay, and this means anything that can compromise production schedules, anything that can compromise the quality of the finished product must be avoided. And of course, if this means that many of the machines of the equipment that you have real-time mission critical requirements, which means that probably you don't want to run the payloads in a Kubernetes cluster, because in that particular case, you want to ensure that everything will operate in a very predictable manner. And once again, real-time operating systems are a mainstay in those types of environments. So from an architectural standpoint, here are a few questions you should ask yourself in order to determine whether you want to run Kubernetes in a specific layer or in a specific part of your IoT and Edge enterprise deployment. So first, how predictable should the latency of the system should be? Okay. Remember that mission critical systems have real-time requirements, and just plain Linux, the real-time kernel or the real-time version of the kernel in Linux is not judged up to snuff by hardcore real-time people. Okay, just the kernel. So add on the top of that a full Kubernetes environment, and you will see that you will never get through that. Okay, so this is really important. Of course. The second question that you should ask yourself is, can you afford to lose data? In the sense that many IoT and Edge applications can afford to lose data without any ill effect. For example, if I'm building a connected home or connected hotel or a digital airport, okay, and I have applications that measure air quality and things like that, maybe it's okay if I don't report about temperature or air quality every second. Okay, maybe every 10 seconds is okay. So, maybe I can afford to lose some of those readings and it won't kill anyone. And that's, where I can certainly take a more stateless approach to the whole application. How constrained are your edge nodes and infrastructure? Okay, you have little to no elasticity at the very far edge. Okay, as you are really at the very end at the leaf devices. But maybe you have some, and then maybe then this gives you the opportunity to run stuff into containers and use the orchestration features of something like Kubernetes, or maybe not. It depends on what kind of hardware you have, if you're operating on battery power or not, and things like that. And finally, how far should the control plane be from the edge? Okay, whether it is in the cloud or in a local data center or remote data center, all of that are important considerations in deciding how you will run the workloads and how you will architecture the whole solution. So Kubernetes is probably a bad fit in the type of scenarios that I put on this particular slide. Real-time applications, mission-critical, highly constrained devices, because even you can slim down Kubernetes to very small footprints. There are limits to what you can do. I mean, there is a minimum of resources that you need to allow to the orchestration engine itself. And then, of course, resources for every container that you are deploying on the top. So there is a practical limit to what you can do there. And of course, if you have heterogeneous hardware, that's another bad fit for Kubernetes, although it's possible now with more recent builds to mix and match a bit ARM and x86 or x64 nodes in a single cluster. This is still highly experimental, and I would argue against deploying anything really, once again, highly valuable in those type of environments for the time being. So, homogeneous clusters are easier to manage in scenarios like that, for sure. And another thing to remember is that Kubernetes itself, or whatever orchestration engine you use for containers, is just part of the ecosystem. It takes really a village to build the edge, which means it literally takes more than a single component in order to deploy a full-blown edge solution. And here you see a little matrix extracted from a white paper we wrote at the Eclipse Foundation with Eclipse projects in colors, and the authors are grayed out just to highlight which ones are from Eclipse, really. But in order to build a full-blown edge ecosystem solution, including AI features, you will need several of those components. And being aware of what's in the ecosystem and what of those components can do for you is really important. So don't focus just on the orchestration engine. There are many, many other questions you should ask yourself, and many, many other components you should pick in order to have a complete solution. Now, very briefly now, what is our vision for edge computing at the Eclipse Foundation? This is EdgeOps. And if you want the full version, you can certainly download the white paper. So there's a QR code there, and there's a link that you can click if when you will have access to the slides in this deck. But really, the full story is in the white paper. But very briefly, EdgeOps is about adapting DevOps to the edge environment. If you do pure DevOps like you do in the cloud at the edge, you will suffer a lot. And especially in terms of continuous integration in delivery. You will do certainly continuous integration, okay, but continuous delivery, not so much, because if you think about it, everyone is in their connected car on the interstate or on the Autobahn in the afternoon. 4 p.m., there are traffic jams. That's not the time to deploy software updates to the cars on the road, right? So continuous integration, maybe. Continuous delivery, not so much. You need to stage delivery in a more intentional way. And this means you need a platform at the edge that will help you really take advantage of what the edge computing brings to the table, so reductions in latency, bandwidth consumption, etc. But we take into account the characteristics of IoT and edge solutions and the specific deployment models that you need to take into account at the edge, like air-gapped environments, for example. Okay, so the best edge platforms will do some of those things for you or facilitate the process of adapting to environments like that. So really, this is what EdgeOps is about, making it easier, okay, to apply the DevOps principles at the edge. And really, from an ecosystem perspective, this is only part of what we are doing at Eclipse in our IoT working group and at Eclipse Edge Native, where essentially we have this kind of reference architecture to position projects, and we have projects for nearly every functional category that you see in this particular diagram. Okay, so the point there is not to highlight any specific project, but really to impress on you that we have a very extensive toolkit, and if you're a bit confused or a bit wary about navigating this ecosystem, I'm there to help. It's my job to help you pick the right components for whatever you're trying to build. So don't hesitate to reach out. I mentioned my social media contacts at the start of the talk. And of course, there's always my book that you can pick. So in the book, I'm using the very same architecture in order to explore various components. And there are code samples and all of that. So that's another way if you find me too intimidating to book a meeting with, then the book is the quieter alternative. And so in Eclipse Edge Native, we have a number of organizations that are strong believers in what we do, like Bosch, Eurotech, Edgeworks, and Kinetics. And we exchange memberships with LFEdge. So this is not about just Eclipse. This is about improving, from an EdgeOps perspective, the whole edge computing environment. And of course, there is at the very end, Zetascale as an important contributor to our Eclipse Edge Native as well. And really, the four most active projects we have in the edge space right now are the ones you see on the slide. Eclipse IOFog, container orchestration at the edge, can integrate or not with Kubernetes, really a fantastic one. Eclipse Canto, which is more recent and does container orchestration as well. But what it does is really more functionally oriented, I should say. So there's a module in Canto for file uploads, for example, and value-added features like that. So it's really interesting. Eclipse Cura, which has been around for quite a while, which is a full-blown solution for IoT and edge gateways. And now it can run containers and has integrations with several AI frameworks as well. We had a talk about it from the AI perspective at EclipseCon in 2022. So I invite you to visit the YouTube channel for the Eclipse Foundation in order to learn more about that. And Eclipse Zeno, a next generation pub sub protocol built from the ground up for the edge. Really fantastic technology. And if you're curious about Zeno and specifically Zeno Pico, the lightweight implementation for it, then stay on for the next call with Carlos. He will tell you all about Zeno Pico. So all of that, as I mentioned, happens at Eclipse Edge Native, where really we have a bunch of people that care about the code first, not so much about abstract blueprints, but really production quality code. And really, we are there to push this edge ops philosophy in everything that we do, whether it's talks like mine or actual open source projects like the ones I mentioned on the previous slide. So my call to action at the end of this talk is really this. Follow us on social media, the working group and the individual projects. Try out the code, IOFOG, Canto, Cura, Zeno, all of that is open source. You can download and jump in straight away. And of course, join Eclipse Edge Native. And if you are interested in that, then of course you can reach out to me and I will tell you how we can make that happen. So thank you so much for listening to me today. As a reminder, you can find me on Twitter for the time being, who knows, as Blueberry Coder. And you can find Eclipse Edge Native at Edge Native WG and edgenative.eclipse.org. So thank you so much. And now if there are questions, I may answer them, or if you are scared, that's fine too. You can recover until the next talk. Thank you.
Thank you so much, Frédéric, for your time and all of that information. It's great, and it's always funny to find out more about you. That you wrote your own book, so that's very interesting. We do have somebody that is asking Cell for the QR code for the slide of the from Develop. Perfect.
Yeah. So I brought it back on screen, and let me paste into the chat if I can, or maybe yes. I should exit presentation mode. So let me up and paste the URL into the chat so that you can download it straight away if you are interested.
Perfect.
There we go.
So there isn't any questions in the Ask a Questions tab. We can give it a couple more seconds.
And yes, of course. No problem.
Perfect. Cell's received it. He's good to go there.
Fantastic. So, of course, Serena, you're not yes. like the developers that we have in the audience. Most of them are developers, I assume. So I was wondering from your non-developer perspective, how much of this resonates with you?
100%. And I think where it gets more real for me is when you put, you really put life situations and the effects. So when you were talking about the importance of software and the timing of when we do those software updates is critical and could be, saving lives at one point or preventing deaths in others. So from somebody that is not a developer, that's the kind of language that I like to be presented information. So
that makes sense.
Yeah. No,
and it seems we have a question now from,
yes.
I suppose, Cell. Do you see a future for Kubernetes on microcontrollers? And the answer to this, well, maybe people will try it. I would advise against it. However, what's more interesting is the usage of microcontrollers in a broad sense as edge nodes, in the sense that, for example, Eclipse IoFog, the IoFog team structured IoFog in a way where you have a central controller that manages the various nodes. And they used in the past a Raspberry Pi Pico as a node, and they were able to run 3-4 containers on a single of those boards. Of course, the management or the central controller was running on the cloud or on the laptop, but they were able to deploy that number of containers on the Raspberry Pi Pico. So is the Pico a microcontroller or not? Maybe for your particular application. So I can see scenarios like that where we use them as nodes append, but really deploying full-blown Kubernetes there, personally, I don't think that's the right deployment model, but that's my own personal perspective. And of course, I'm busy speaking or talking about things and not implementing them in the real world as you are. So if there are people in the audience that have done that or hope to do that at some point, then of course you can do that. And the slides I think will be made available when we'll make the recordings available as well, because Serena requested the slides from everyone. But my decks are always public. Let me check. So I will put the URL to the deck I used today right away in the chat. Let me just make sure that yes, everyone has access. So that's good. So
that's awesome. We also have another question from Mark. With your experience, what is the Kubernetes scalability for IoT use cases?
Well, generally speaking, in itself, Kubernetes is certainly a highly scalable type of environment. That's the whole point. It really manages scalability well for stateless workloads. Now, we could discuss till the end of time about, how would I say that? Whether it's a good choice for stateful workloads. Some people have attempted that in the past, and with a varying level of success. Okay, but in any case, what I want to say there is certainly by itself, Kubernetes can scale. Now, the question is, what are you trying to scale on it? Okay, and here comes the question of the architecture of your applications and how you are coding them. In the sense, it's not because you can run containers at the edge that necessarily your code, will be power efficient and size efficient enough to run well in that particular location. So you need to pay attention to that. And Kubernetes in itself, if your code is bad, Kubernetes can only orchestrate the containers, so it will orchestrate beautifully your bad code. I'm not assuming, by the way, that you're writing bad code, but certainly that's always a possibility when we write code, and I wrote my share of bad code in my career. So, in other words, Kubernetes in itself can scale, and especially for stateless workloads. But if your workload is stateful, and many AI-driven workloads are stateful to some level, okay, then maybe Kubernetes is not the right choice. And of course, then comes the consideration of the design of your applications themselves.
Okay, awesome. All right, so thank you so much, Frédéric. And we'll be back with everyone in just a few moments with Carlos. He will be going live at 11:45.
Excellent. Thank you, everyone.
Thank you, everyone. Welcome, Carlos. Thank you for joining us today. And Carlos Guimares is going to be speaking about Embrace All Little Things with Zeno Pico. Carlos, over to you.
Thank you very much, Serena. Let me just try to share my screen. Yep, here. So just let me know if you can hear me and see the full screen of the presentation.
Absolutely, yes.
Okay, thank you very much. So first of all, welcome everybody. I mean, it's a pleasure to be here presenting Zeno and Zeno Pico to all of you. And I also want to thanks Frederick for the small teaser that he made for Zeno in the presentation just before, and to provide such a clear overview on the edge and what this is of the cloud to things continue, which I believe will make this presentation easier to understand. So my name is Carlos Guimarães. I'm a senior technologist at Zscaler, and I'm currently one of the persons leading the development of Zeno Pico. And I will tell you a bit more about what it is. Zeno is a project part of the Eclipse Foundation, and today we will see how it fits. So we'll see it from the perspective of embedded systems and low-powered networks, and how it was designed to fit such environments. Okay, so that's why it's embracing all the little things with Zeno Pico. But first, let me recap some of the Zeno concepts. So I'm pretty sure that some of you already know what it is. But for those that don't know it, I think it's important to explain some of its baseline concepts. And so the motivation behind Zeno was the lack of, let's say, a single solution that could target the entire cloud to things continuum in what concerns data distribution, and also a bit of the segregation of ways to address data in motion, data at rest, or computations. Okay. So Eclipse Zeno is a solution that was designed from scratch, and its purpose is to unify data in motion, data at rest, computations, really from the embedded microcontrollers up to data centers in the cloud. So it's a single solution, a unified solution that targets the entire cloud to things continuum. And it does that by providing a location transparent API, by following two different communication models. So by doing pub/sub or distributed queries. And it does that in a very high performant way. And I will show later on some of comparison results. And on top of all this, it also facilitates some enhanced features that usually developers and users developed by themselves on top of these kind of data solutions, such as the integration of geo-distributed storages or the integration with third-party technologies in a very plug-and-play fashion way. So Zeno is capable of running everywhere, so not only in the continuum, but also in terms of the OSI stack. So if we see here, Zeno can run on top of the common UDP, TCP, QUIC, TLS, whatsoever, so protocols that are on top of the transport layer, but we can really go down to the data link layer. So nowadays we can run on top of some non-IP protocols like Bluetooth, LoRa, or even serial devices. And this provides a very powerful solution when you need to integrate devices that are constrained, that work on premises, that don't rely or don't support an entire IP stack, and you want to bridge them and expose information up to the cloud. Okay, and later on I will show a little demo where we are doing it. And then, as I said before, these allow Zeno to be deployed, and not only to be deployed, but to be usable on embedded and constrained devices. And then in addition to this, so Zeno can form or can create systems with different kind of topologies, which will depend on whatever is your needs from your application or from your system. So With Zeno, you can deploy a peer-to-peer topology, either it's in a click, so a full mesh, or a partial mesh, where nodes can directly exchange information between one another. But you can also have a brokered mode. And this is actually important for the embedded world. So if you have a device that is constrained, that doesn't have too much computing or networking capabilities, you might want to offload some of these functionalities or features to a more powerful node, which can be one of these routers here in the figure, or a peer that will act as a middleman or intermediated node between the communication parties. And then, so we have also these routers, which basically allows you to expand your Zeno infrastructure or your Zeno peers towards different geographical locations. Yep. So here, for example, if we can assume that, so the two peer-to-peer topologies that we see here on the left and on the right could be, for example, two fleets of robots that are doing robot-to-robot communication, so they can act as a swarm of robots. And for some reason, we want these two fleets to communicate with one another. Okay, so they can select one peer as the master node that can relay the information of the entire fleet. But then on the bottom, we could consider that these are clients, and let's say that they can be applications running on the cloud that a supervisor can go and see what is happening, checking some monitoring information, and so on. So in the end, all these modes and topologies, so Zeno allows you, or doesn't impose you, an architectural choice on how to deploy things, but it really gives you the freedom on what kind of topology you want to build. But so what can you do with Zeno? So these are very small examples. So you can do PubSub, and here you use PubSub to publish. So we have a sensor on the left that is, let's say that is a temperature sensor that is in the kitchen. So that room/kitchen/temp is how we define our key expression, so the identifier of the data. And this node is publishing information to all the available subscribers. So everything that matches to this key expression will receive the data. Okay, so on the right side, you can see that there are some wildcard expressions, and basically this is a way for you to be able to subscribe to multiple key expressions in a single declaration. Okay, so for example, the second node is subscribing to room kitchen/wildcard/star, right? So which means that he wants all the sensors that exist in the kitchen. But you also can do query reply, so more on this kind of request response communication model. So, and this is particularly useful when you want to request data on demand. So let's assume here that, well, you have your device and you just open your application and you want actually to know what is the temperature in the kitchen, right? Or on your entire house. If you didn't have the app on when the sensors published information, maybe you lost the information. So you want to query it, and this query will go to all the, in the same way with the PubSub, it goes to all the matching key expressions. In this case, we call them queryable, and all of them will reply, and Zeno will do some kind of consolidation of all these replies that are then delivered to the original querier. Okay, I'm going to skip here the details on the consolidation, but basically it allows you to receive, for example, the latest or the most recent reply from all the queryable. So let's assume here we have 3 sensors. You might just want to have the most recent reply, or you might want them, but you might want to have only replies that are more recent than the ones that you already received, or you want all of them. Okay, so this is pretty much what we mean by consolidation. And then if you mix the publish, subscribe, and the query replies, you can somehow implement some distributed storages. So we can see these as, so the storage will get all the data that is being published by the sensor. So to some extent is a subscriber. And then all this data is going to be stored and can be queried by different nodes. And nowadays, if you want to have this kind of behavior, either pub/sub or query reply, you might need to stitch or to adopt different solutions. One for the pub/sub, another one for the query replies. And eventually, you might also need to adopt different solutions. Either you are targeting the embedded world or the edge and the cloud, which have more powerful devices. Then Zeno is extensible. And this is done by enhancing the baseline functionality of Zeno with plugins. So you can instantiate different kinds of plugins on top of Zeno. And this is especially useful when you need to interact with other technologies. And as an example, if we have our legacy system that is working, for example, on DDS, it might be very difficult to update all the nodes overnight, right? So it might be that you have a period of time that you have your legacy system running with your next generation system. So you need somehow to make them communicate, otherwise we'll have some information silos or communication silos where one part of the devices cannot communicate with the other part. So for this, we provide a set of bridges, for example, for MQTT, DDS, OPC-UA. It's not yet finished, but it's something under development. So there are already these set of protocols and bridges that you can integrate with if you are using Zeno. Okay, then we also have some REST API that might be useful for some use cases. And then in terms of storages, you can adopt either time series or key value storages, or even file system or in-memory storages. Okay, so this was a very quick overview of Eclipse Zeno. Okay, I can provide later on or in the chat more resources about it. But what I really want to focus today is on the Zeno Pico and how Zeno is suitable to work on microcontrollers and the embedded devices and low-powered networks. And well, if you have been working with it, you know that it's an ecosystem full of challenges for several reasons. So the first one is the scale of the systems, which basically depends on the target device and the specific task that it might be performing. So you might have different microcontrollers, MCUs with different CPU architectures, which, well, not only have different instruction sets, might have different NDNSs, or might have different word sizes. And the design choices, so what you decide to adopt for your solution might have a big impact on how performant it will be, right? So as an example, so if so in what concerns the word size or the register size of your CPU, although it's possible to represent, for example, integers higher than this, by doing so, you might be impacting the overall performance of your application. So with Zeno, we take this into consideration because we wanted to accommodate different type of systems, either they are 8-bit, 16, 32, 64, whatever, right? So when Zeno boots, so it needs to establish a session, and there are a set of parameters that are negotiated between these two sessions. So either a client with a peer, peer to a peer, peer to a router, what doesn't matter. So this set of features are negotiated, and one of them might be the size of variable size integers. So in Zeno, integers are represented as a variable size, which means that if your microcontroller is 16 bits, you can negotiate that, look, I don't want to use integers that are bigger than 16 bits. So let's agree that that will not happen. And that's what Zeno does. Then the developer might need to decide which target platform he will adopt. So we might rely on any kind of operating system, so either general purpose or real-time operating systems. And in turn, this can be open source or proprietary as well. So we didn't want to do Zeno for a given real-time operating system, for example, since we are talking about embedded and microcontrollers. So Zeno itself, or Zeno Pico, is platform agnostic. So, which means that the set of implementations can be extended to new platforms very easily and with minimal code extensions. So this means that if you have a new platform that you want to adopt, that you are using and you want to adopt Zeno, and Zeno doesn't have support for it yet, it would be very easy to do it. Okay, so we have an abstraction layer that allows us to very easily port Zeno and Zeno Pico to new platforms. And I will show you in a couple of slides which ones we already support so far. Then I think this is the most well-known challenge, which is regarding the availability of resources, especially memory and space, which tends to be very scarce. And there are several reasons for this, like they want to decrease the costs. There is a limited available area for memory, also because of power consumption reasons. And with such scarce resources, the tasks usually deployed in the microcontrollers are also very specific and limited. Okay, so while implementing Zeno and designing Zeno, we knew that users don't want to use space with their libraries, right? So they want to use the space for whatever they want to develop. So if you know what your application will do with Zeno, you can enable or disable features that that you don't need for your specific application. And by doing so, you can reduce the footprint of the entire Zeno stack. And again, so this goes in line with the things that are negotiated that I mentioned before on the set of features that I negotiated during session establishment. So if you decide to disable a feature, this will be notified to the next entity, so to the Zeno entity that you are connecting to, and the operation will be adapted accordingly. Then another challenge is regarding time, which, as far as I know, is not guaranteed on microcontrollers, and this might be either because, you don't have a real-time clock, or simply because the clock synchronization is not possible. And usually they also have broader time granularities, and many platforms still represent time as a 32-bit integer, which, if my math is correct, it will roll over in 2038, and this might be a problem if you have applications that will run for years in production. So knowing this and knowing the limitations that time might be, Zeno, timestamping of operations in Zeno is opt-in. So if your microcontroller doesn't have time capabilities, or it's not synchronized in time with the rest of your system, so you can send or trigger whatever operation you want to do without the timestamp, and the first hop in the infrastructure will do it for you. So in this sense, we assume that the infrastructure is synchronized in time with the remaining nodes. Only the embedded or the microcontrollers might be the critical part. And then maybe this is one of the key challenges for microcontrollers, which is energy efficiency. And here we might be talking about devices that target very low power consumptions with limited energy, and simply because the device might run into the wild for several years with whatever battery was provided to it. And there are several strategies to achieve this. So either by having different sleep modes or by adopting power-friendly programming patterns. And so the power-friendly programming patterns is one of the things that Zeno adopts or relies on the implementation. But it also provides a set of features that make it energy efficient. And just to give you some examples, so it can cope with different sleep modes in the sense that, so since Zeno can run on top of different protocols of the Z stack, you might rely on a protocol that is not connection oriented. And then Zeno itself will provide additional mechanisms on top to ensure that you have some kind of keep alive or whatsoever. But this means that you can go into sleep mode, and when you wake up, you can reestablish the session without the other party even to know that you went to sleep. Then Zeno also provides a very low wire overhead for data transmissions between 4 to 6 bytes, which, if we think of transmission of data, consumes energy, right? So if we can reduce the amount of overhead from the the overhead that is not actually the payload of bytes of data to be sent, we can also reduce the energy consumption of the device. And then regarding still about the sleep, I forgot to mention. So when you do PubSub with Zeno, you can do a PubSub with pool capabilities. So what does this mean? So you declare your subscriber, and whenever information is pushed to you, it will be kept on the last node, on the last hop on the infrastructure towards the subscriber. And then it's up to the subscriber to decide when to pull this data. And so with these, we kind of mix a PubSub with the pull, so with the query, but this also allows the node to go to sleeping mode, and whenever he wakes up, to request the information that was eventually sent while he was in sleeping mode. And then many of these environments or of these devices, they rely on low-powered networks as a way to save energy and to increase the lifespan of these devices. And usually these networks, so they have small MTUs, they have low data rates or rely mostly on gateway or mesh-oriented communications. And many don't even rely on IP-based technologies. So as I mentioned before, so Zeno can support different kind of transport, either IP or non-IP, the very low wire overheads, the support for connectionless or connection-oriented protocols, the fact that it can act as a client, a client or a peer that connects to a router or to other peers. So all of these makes Zeno suitable for the embedded. But of course, in the end, when you are developing your application, you need to understand and to keep a balance between what do you want, between performance, footprint, energy consumption. And this actually depends on the application the requirements that you have for your application, and actually how you expose and consume data between your applications in the embedded and the rest of the continuum. In any case, I strongly believe that Zeno is a solution that gives you several handlers on how to tweak this continuous balance. And here is just a quick summary of what I just mentioned and some of the features. I will just skip it for the sake of time. Okay, so at this point, I'm assuming that you might be wondering how actually you can use Zeno in your microcontrollers. And Zeno Pico comes at rescue, which we say that is our smaller dragon. And basically, it's our implementation that is tailored for embedded systems. So the main implementations of Zeno they are written in Rust language, but Rust is still maturing and still needs to grow a bit before being adopted widely in the embedded. So it's happening. We are seeing a growing number of initiatives and adoptions, but we still believe that the entire ecosystem is still relying on other languages like C. So Zenopico is one of, well, it's a parallel implementation, okay? So it's fully written in C. And yeah, so we see it as a critical part of applications that are nowadays developed for the entire continuum, because we are seeing more and more that robotics, automotive, Internet of the Things, healthcare, energy, they are all exposing information from the devices to the edge or to the cloud, either to do AI, either to do analytics, to crunch some data, to monitoring. So they are all starting to expose this information from their embedded devices. And also, they run across a variety of different kinds of networks that we are not used on our daily basis, especially if we are using our laptops or mobiles. So, as example, LoRa or serial-based communications. So, as I said, Zenopico is our small footprint Zeno implementation that is tailored for or optimized to run on microcontrollers. So it's fully implemented in C, both the Zeno stack and the set of APIs. And as I said before, it has been implemented in such a way that it can be easily ported to many platforms or frameworks or even communication stacks. And here in this kind of table, we have some examples on where we already validated Zeno running into. So we have several platforms from NXP, Nordic, Expressive, STM, that we are already able to run the Zeno Pico there. But then in terms of frameworks, so we have Arduino, maybe the most well-known one, but then also Zephyr or EmbedOS from ARM, NetX or Expressive. And then, as I said before, in terms of communication, so Bluetooth, LoRa, serial, Wi-Fi, Ethernet, and then some more specific to some of the vendors like ESP Now. We also have some support for this kind of communication stacks. So these are the kind of devices that Zenopico is targeting, but I'm assuming that everyone here knows some of these boards actually. But then I also want to share some insights about the developer perspective. And mainly because we see Zeno and Zenopico as the same set of, well, they are the same solution. So they rely exactly on the same network protocol, but as well on the same set of APIs. So no matter if you are using our Zeno-C bindings that rely on the Rust implementation or Zenopico, we will have the same look and feel when developing an application. And in fact, you can almost copy paste one to the other, okay? But there are some things that you might need to change, or because we believe that is a paradigm that is more tailored to embedded developers. And this is regarding user configuration, the way you manage your tasks, or even the way we convert some of the key expressions to string. So in terms of configurations, maybe this is the biggest difference, because the main implementation heavily relies on JSON files. And on the embedded world, you might not have these kind of files, or you don't have a file system. So you might want to embed your configuration parameters as part of your code. So this is a bit, so you have two snippets of code here on the right, and this showcases how you configure your Zeno session, either with using ZenoPico or using ZenoC. And then ZenoPico also allows you to have a more fine-grained control on what you can enable or disable in terms of features, and to do them at compile time. Then in terms of task management, so it supports both multi-thread or single-thread. And we believe that providing both approaches to the user is beneficial, because, well, we want to let the user to decide which kind of model he will use for their applications. So if you go into single thread, you might need to explicitly trigger the execution of the read or the send. If you are on the multi-thread, you just need to be responsible for spawning or destroying these tasks. And then the way we convert key expressions to string, and maybe here I should provide a bit of more context. So in Zeno, and it's kind of an optimization to reduce the overhead that goes into the wire. Let's assume that we have this key expression, which is, so it was room / kitchen / temperature. So sending the full string every single time we need to publish some data, well, it's lots of overhead, right? So basically, when you declare your intentions to publish that specific piece of data, you might also want to associate an integer value with it. And by doing so, instead of sending a full string, you might just send one integer. And this actually allows you to reduce a lot on the wire overhead. Then what happens is, somehow you need, well, the stack needs to keep state on which mappings were done. And these can be nested mappings, okay? So if we have quite some mappings, nested mappings, we might have a big state or overhead to store, and we might not have enough space for that. So basically, with ZenoPico, when from your user code you want to resolve a key expression to a string, it might be that it goes through these nested list of mappings, and in order to reconstruct the full string, which is not actually happening in the main implementation written in REST. And finally, so the API that we are implementing in C, either in ZenoC or ZenoPico, tries to replicate one of these big advantages of REST, which is an explicitly ownership model. So we decided to try to replicate it a bit, because it might allow our users to have a better memory management, to identify memory leaks, or double freeze can also be avoided. So for that, every type, for example, we have a Zeno session. So for every type, there is an own type and a non-own type. So in this case, Z own session or just Z session T. And then we provide a set of ownership helpers for you to handle these handle these data types. So either is to check if a value is valid, to loan it to the API, to move it to the API, or simply to drop, which would be the equivalent to releasing its memory. And now let's have a quick look on the performance. And well, here we have some comparative results against MQTT, OPC-UA, or DDS XRCE. So all our tests are publicly available. So you can download the perfs and run them yourselves in case you want to validate the results that we are showing here and in our blog. And you can see here that ZenoPico actually is performing several orders of magnitude above the other solutions. Either if it's for smaller payloads of 8 bytes or for bigger payloads of 8 kilobytes. And in fact, we can see that even for bigger payloads, it still performs better than all the other solutions for smaller payloads. And yes, and note also that, for example, DDS XRCE, after 256 payload size, we were not able to receive any message, and kind of a similar behavior happened to OPC-UA when messages were bigger than 4 kilobytes. So more details can be found on our Zeno.io blog post. I forgot to put here the link, but I can provide it later on in the chat. Then we also have some results in terms of latency. So in this respect, so ZenoPico, when it's in brokered mode, it performs very similar to the remaining solutions. But when we can go really peer-to-peer, we can reduce almost this value by 3 times. And actually, from our tests, we got a minimum latency of 12 microseconds. And then in terms of wire overhead or the protocol overhead, so this is the results for the different stages of your application when establishing a connection with Zeno. So I want you to note that the discovery, the open, and the close are operations that happen a single time in the entire execution of your application or of your session, and data is actually the periodic or the cyclic operation that is being used to send data. So most of the overhead will come from the data, and there you can see that Zeno is half of the overhead of MQTT, and well, more than half when compared to DDS, XRC, and even more when compared to PCUA. And even for the remaining operations, I would say that Zeno is either the lowest solution introducing more overhead, or the first one. Okay, so it's very on par with MQTT, I would say. But again, here we should focus on the data operation because it's the cyclic one. And then in terms of footprint of Zeno, so this is a table. I will just keep it for reference. So this table shows the footprint of ZenoPico stack when compiled with different features enabled or disabled for different platform frameworks. But note that if we really want, we can even tweak the stack even more, so we can even have less overhead. So it really depends if you really know what your application will need or not. So after all this, can we say that Zeno and ZenoPico are the same? And the short answer is yes, definitely. So they share the same wire protocol, they share They share the same set of functionalities. They share the same API. It's just a different implementation that focus on the aspects that are important for embedded. And on top of this is C99 and MISRA compliant. But, well, I've been talking too much, so this part was supposed to be a bit more interactive for the hands-on, but I will show some of the demos where Zenopico is being used. So here we have, well, it will not be hands-on, but so this is a Turtlebot 3. For those that know, it's this kind of educational robot that comes also with a Raspberry Pi on top for all the communication aspects and to run ROS and DDS. And since Zenopico could run on the microcontroller and actually be able to communicate data outside of the robot, we decided to port the applications running on Turtlebot on the microcontroller and to have this small demo. So here on the left, so is the Turtlebot that we stripped out the Raspberry Pi. So in the end, you have a cheaper, smaller robot. And on the right, we have an ESP32 that is together with the gyroscope sensor. And you will see that whenever you tilt let's call it the controller, it will make the robot move. And in this case, both the controller and the robot were connected via a Zeno router that we were running in the edge, but they could have been established peer-to-peer connection. So this is the result. So as you can see, when you tilt the device, you can actually control the robot. And so maybe you don't notice it here, but when you are playing with it in real life, you can have a better look and feel and to see that it's very responsive and very low latency when you move and how the robot reacts. Then the second kind of demo here is how we are using Zeno to expose data that is running on a microcontroller that only has serial communication and actually sending it to the cloud and then storing it on an InfluxDB storage and plotting it in Grafana. So in this case, you can see here in the bottom, I think you cannot see my pointer, but so you can see that Zenopico, so the one with the microcontroller with the little sun icon, so it's connected to a Zeno router via serial. And then this Zeno router is the one bridging towards the cloud. Okay. Then the InfluxDB is subscribing to the topics that are being published by the sensor, and then we can plot everything in Grafana. So this is kind of a snippet. So I'm going to try to move the video. So you can see, So you can see here on the left that these are some of the values that are being published by the sensor. Okay, so basically here what is happening, I'm just redeploying the application with some Zeno capabilities. Here on the bottom is a Zeno router that will be able, that is listening on the serial and also publishing or connecting to the Zeno router and storage in the cloud. So, yep, so you can see here it registers the key expression, right? Temperature and humidity. And then here in Grafana, we'll be able to see that the values are being published. Okay, so here is not very responsive because it's updating the values every 5 seconds. But if I move it forward and change the scale, you'll see that here it published the value. And if I show the values being published in the last hour, you'll see that things have been publishing. Okay, so the small maybe horizontal lines, it was because the sensor was not running or it was not publishing values. Okay. And then the last demo here is showing the data exchange between two microcontrollers using Zeno on top of Bluetooth. So here we have an MCU that has a light, and the other one is just triggering the light to go on or off every 5 seconds, if I'm not mistaken. But it could be any kind of sensor publishing information that would trigger the change in the light. And in this case, so they are establishing a peer-to-peer communication using Bluetooth and making use of a kind of multicast transport. So if we have more devices, the same message would reach all the devices that were in this multicast transport. And this is it. So let me just move forward. So you can see that. Well, you can see the one here on the left. So it's going to send values off or on. And then when I turn this one here on the right, let me just, yep. So we'll connect via Bluetooth and declare to the same key expression, which is the one being published by this node here. And whenever it says on and off, you can see that the light will switch. Okay, so these are very simple demos, but the purpose is just to showcase parts of the functionalities of Zeno or Zeno Pico. And yep, so that's all. Just to sum up, so Zeno Pico is again a lightweight implementation of Zeno that is tailored for embedded systems, microcontrollers, and constrained networks. You can also achieve with Zeno Pico and with Zeno in general very high throughput, very low latency, and small footprint and minimal wire overhead. And the one in particular for embedded, it follows MISRA C guidelines to make it compliant with many industrial standards. So don't forget to visit our Zeno website. We have a section on the blog. So from time to time, we publish more technical oriented content explaining some of the details of Zeno. So have a look at there for more details. Also, go to our GitHub page and star us, either the Zeno Pico or the main Zeno repo, and join us on Discord. We really like to have the community engaging with us. So the entire team is always there to provide support and to discuss any problem or feature that you would like to see in the future. And yes, with that, so thank you very much for listening, for your time. And if there are any questions.
Thank you. Thank you so much, Carlos. We do have two questions. So the first question is coming from Marta. Do you have code and data footprint for typical processors?
So the footprint that we have regarding the size that the set of Zeno Pico library will introduce to your firmware is what is presented here. Of course, these are indicative values. Okay, so it really changes. Well, it have changed already because we have been updating the code since I took these results. I'm not sure if I understand the footprint for typical processors, but I believe that this is the kind of data that Marta might be asking for. Yeah.
Okay. Marta, if you'd like to provide, if you have a follow-up, feel free to put it in the chat. And then we have a second question from Frédéric. Will Zeno Pico will be made available in other languages than C?
So we are looking at REST. So we are looking on how to use our main code base which is written in Rust, and how to adapt it in such a way that it can run on embedded devices. So as I said, there are lots of initiatives appearing, adoption growing. So we also want to be in the front line for that. It's something that we are looking. We are already doing some of the required changes in terms of the no STD support. But we also believe, and I believe, that the community still relies, I would say, from what I was able to see, around 80% still relies on C, C++ languages. So I think we still need to provide support in C, no matter if we provide in Rust or not for the embedded. But yes, it's something that we are looking at.
Okay. Beautiful. All right. So it doesn't look like we have any other questions. Thank you again, Carlos, for
Thank you very
the
much.
excellent presentation, and you have yourselves an amazing day. And we have next up is going to be Mark at 12:45. So stay tuned 9 more minutes before Mark joins us for his presentation. Thank you.
Thank you. Bye-bye.
Hi, Mark. How are you? Welcome. Oh, we don't hear you. You can't hear me. We can't hear you. Let's try the sound there on your end. You are on mute. And I think it's just because you're switching out your headphones right now. No. Okay.
Okay, now no.
Yes, now we can hear you.
Okay,
Awesome.
can you hear me
Thank
well?
you. Yes. Yes. Thank you, Mark. This is what it is. So we
No, I
are
was
live.
mute and I couldn't unmute me.
That's okay. That's okay. Welcome, everyone. We have Mark with us. He's going to be presenting this amazing presentation. So I'm going to pass it over to you. And please, if you have any questions for him throughout the presentation, drop it in the Ask a Questions tab or click on in the chat. Thank you so much.
Yes, sorry for these technical problems. Let me share my screen now that I solved my problems. Let us start with this. And if you are on podcast mode on this, please go back for a second to the crowdcast, because I would like to ask you some questions to start this. If you're listening this or watching this, I would like to talk about the Ming stack, which is something that I have been working during the last month maybe, which is like it's a stack that we are working with some people from the community to try to bring more developers or try to reduce the friction to developers on the IoT and the edge. Okay, and I hope that you will like it. But I have a first question for you. This is why I wanted to bring you to the crowdcast. So, how did you learn programming? I want to read all the different answers on the chat, please. I can wait. I have here some drink.
So
Frederick.
Yes.
What is this? You have to tell us more about this. But yeah, more people. Or it's only Frederick listening.
Oh, no, we got a lot of listeners here.
Yay.
Yes, we have over 257 registered attendees, and we have 41 right now with us live. Oh,
oh, nice. Thank you. More. I need to see more people. How did you learn programming? Please go to Crowdcast. Self-study, nice. And what did you, Thomas? What did you study? What was your first programming language? Where did you learn programming? It's okay if it was on the latest laptop from MacBook or. Okay, nice, Robert. What did you learn? Pascal, nice, Java, cool. Anyone else want to share? How did you learn programming? Sinclair, oh my God, basic. Pascal, later C++, nice. Thomas, thank you. I tried Pascal actually as well, but it was not my first. Okay, see Thomas that, yeah, learn a lot of different languages. Alfonso, C++, nice. More, please. Python, nice. Visual Basic, why not? Carlos, good. Okay. Anyone else? So this is how I learned programming, actually. I learned programming with this book. I had, actually, my parents gave to my sister as a present, this I was about to say this laptop. It was kind of portable, but yeah, not a laptop at all. This Amstrad CPC 6128. I don't know if anyone here had the same computer like 40 years ago. So I actually got this huge book, and I start reading page by page and just writing all the codes, all the basic programs and applications. And this is how I learned programming. This is maybe because I'm not a great programmer. I started coding with BASIC. But yeah, maybe this is another story. Then I have another question for all of you. So did you use any framework or stack at some point, not at the beginning, but at some point to reduce the friction of the so I think it was a really great comment here from Robert, actually, learn what is necessary to solve my problem. So when you detected a problem and you needed to use something specific, did you use any framework or stack to reduce the friction to solve that problem? Anyone? I don't know. So a good answer could be like a specific, I don't know, framework for, I don't know, Python or no, to reduce the friction to do some specific things. Or I don't know, probably Frederick used tons of that. Feel free to share. But yeah, I'm looking forward to get the crowd, like a crowdsource list here. Let's see. Arduino, yeah. Oh wow, that's a good one. Yeah. Actually, Arduino and the Arduino IDE and all the libraries that the community created, reduce the friction completely if you want to use Arduino to do some specific things. Okay, Spring OS stack. Thank you, Alper. What else? I tried Ruby on Rails. Oh, wow, that's a good one. That's a good framework. Yeah, that's Platform IO. Yeah, I still need to. I'm using it, but I'm still a beginner for Platform IO, and I'm fighting between Arduino IDE and Platform IO, but completely reduce the friction. Yeah. Awesome. So I start using this. So let me explain my story as well. So I start actually coding websites about 2000 probably, a little bit earlier. And I started using this framework to reduce my friction because I started from scratch, and it was really hard to bring a website on production at that time. And then I discovered this LAMP stack. I don't know if anyone, I want to see on the chat people who use the LAMP stack, which LAMP stays for Linux, LA for Apache, MySQL, and PHP. Okay, and that was coined by a German developer in 1998 on a magazine, on a German magazine, and then O'Reilly just made it super popular among developers and actually reduced the friction a lot to developers who wanted to get into the web fever. I don't know if you remember, before the .com bubble, that was about the 2000. So a lot of developers wanted to move to the web, and it was kind of hard. I was there, and stack like LAMP just reduce a lot the friction to get a web developer. Anyone use LAMP stack here? If it's no, you can say no. Oh wow, Frederick. I also use this Java. I don't remember what they call it, Java something, to create websites. And sorry, I just gave up. But so actually, I really think that LAMP. I'm going to talk about LAMP in some minutes, but help to a lot of developers to get into the web development, and why LAMP succeeded. And these are my reasoning, but I think it helped a lot of developers to get into the web. It used open source and free technology. Okay, it was flexible and scalable. You could put something on production using the LAMP stack. Then if you needed to scale that was a bit more tricky, and you get the load balancers, etc. That was another story, or replicate databases, etc. And the other good thing was it had a wide community support, as mentioned. O'Reilly just made it very popular. And I think all the communities related to Linux, Apache, MySQL, and PHP were there to help anyone who had any problem. Okay. So we are here on these Eclipse IoT Edge Days. What can we do for IoT and Edge? Do you think we can do something similar of what happened in the early 2000s with web developers? How can we reduce friction to developers that maybe, they are Java developers and they want to get into the IoT because they want to, change their life as a developer, or they want to, I don't know, hack some IoT devices. What can, or they want to do like a project, a side project, or not, or like a serious project for their companies. How can we reduce the friction to these developers who are not used to fight with the IoT and Edge and all of the problems with hardware that we have? How can we help them, and how can we enable them to get into the IoT and the Edge? And what needs a developer to run something like the LAMP stack that was created for web developers for the IoT and the Edge? So this is where for example, hardware like Raspberry Pi, Arduino is a good example, but maybe it's as a 8-bit microcontroller, it's not super powerful. Okay, so I will focus more on single board computers that can run Linux operating systems such as Raspberry Pi, which is to be inexpensive, and hopefully it will be inexpensive again in 2023. But with devices like these and software, and open source software like Node-RED and others that I'm going to show you in a second, so I think it's possible to make something for developers who want to get into the IoT and the Edge, as me as a developer wanted to get into the web in the 2000s, and the LAMP stack was my solution. And actually, Embedded IoT, who is Alex Lennon, actually he's a Berlin ambassador, and we talk a lot. He mentioned that like 4 years ago, he introduced this concept of the main stack that I'm going to introduce in a second, as like enabler or facilitator to start projects, not from scratch, but with like a boiler template or with a template, so you can start creating innovation on the top of some service, open source service that can help to start projects. So he introduced me into this concept of the main stack. Welcome to the main stack. And what does it mean, main? So main stands for Mosquito MQTT, which helps on data communication. If you don't know about MQTT, basically MQTT is a published subscription protocol that helps for real-time communication between devices and cloud services, or MQTT brokers. Actually, we have InfluxDB, which is a time series database for data storage. We use Node-RED, which is as well an open source software that helps on, it's a no-code, low-code system for data processing, data acquisition. And basically, it allows you to do all the workflows between data acquisition, data collection, and what you do with the data. You can transform the data and send it somewhere else. And finally, Grafana, just to visualize it. It's interesting that Grafana and InfluxDB are very well integrated each other. So usually the default data source for Grafana is InfluxDB. So it's pretty straightforward to query data from InfluxDB on Grafana. Okay, and it's as well open source. Usually I architect these services like this. Okay, so when I need to start a project, and I'm going to give a lot of some examples in some seconds, but actually, I cannot show you, but I got like a solar panel here with some, I cannot show because it's everything connected, but I have a charge controller for my solar panel that I got, and I have an inverter and a battery here. And I wanted to get information about my solar panel. I got a Raspberry Pi, I connected through USB to my charge controller, and my engineering mind was like, okay, maybe I can make a script that pulls data from the charge controller. But then I said, okay, wait a second, let's try to use the main stack and just build the application on top of this and use Grafana to visualize the data, get Node-RED to just pull the data from the controller, and just use Mosquito in case that I want to publish, subscribe the data somewhere. So this is how I actually accelerate my IoT application, not starting from scratch, but starting with something that already can work straightforward on any IoT device that can run on Linux operating system, let's say. Okay. So how can you get started? Okay, here I have to explain that I'm developer advocate at Belena, okay, belena.io. So I'm going to talk about different things, but one of the things that I'm going to talk, it's about containers in a second. So at Belena, we only run containers on the top of Linux. So we have two choices as engineers, okay? As engineers, we love to, what I call the die-hard method. So yeah, I can do this on a weekend, let's do it. And you can fight with all the software running on your host OS and everything, and finally it works. Or we try to reduce the friction on Belena and just create this deploy with Belena button that it just basically simplifies everything. But yeah, on this as a shameless plug, I'm going to show you why I use Belena. On the other hand, if I mention Belena, means that anything that I'm going to show you from here, it's compatible with any Linux operating system with Docker installed on it. So if you have any x86 device or any Raspberry Pi or similar and you run any Linux operating system and Docker, everything is going to run there. Okay, yeah, and if it doesn't run, just let me know. But for Belena, and actually this is something that I want to as well push to all the developers for embedded IoT edge devices, is we should start using what I used to call the 21st century tools on the IoT and the edge. I'm tired to see projects that needs Windows 95 or Windows Vista to run that PLC on the factory, blah, blah, blah. So we should start pushing developers to start running new toolkits and new tools on their IoT edge devices. I think it's being demonstrated that, for example, Docker containers run perfectly and doesn't add any overhead on IoT or edge devices. So I strongly recommend that if you need to start any project, you don't know anything about containers, just give it a try, because you as a developer, I strongly recommend you to start learning this new type of technologies that will help you not only on developing one specific project, but as well on all the application life cycle of the application, and will reduce a lot the friction and the updates and other things that you need to do on the applications. Okay. So actually, one of the missions of Belena, like a long time ago, when actually Belena was the first one, it was called Resin before. It was the first one who ran Docker containers on a Raspberry Pi in 2013. And the goal at that moment was that, so the question was, why fixing a bug on a website it's so easy and fixing a bug on an IoT device is so hard? Why cannot we do like the life cycle updates of the website? Why cannot bring that into the IoT devices or the edge devices? And this is what actually we achieved, okay, at Belena. Another shameless plug. So if you want to try Belena, it's free up to 10 devices. So you can connect up. I will show you less than 10 projects today. So everything that I'm going to show today, you cannot run for free. You can run it for free on Belena, okay? So in case that you don't know what is Belena, maybe anyone use this software. I don't know if we destroy any SD card or USB drive here on the chat. Yes, no, yes. I don't know if this is good or bad, if I don't get any answer. Yes, Frederick, you used Etcher before? Okay, so if you use Etcher, you use Belena software. So Etcher, basically, for people who don't know it, it's a software, an open source software, actually, that we made at Belena just to reduce the friction to flash SD cards or USB drives with new operating system images. Okay, and there is DD as well, of course, but we had a lot of questions on support of customers and developers from the community that didn't know how to use DD. So what we did actually was to create a tool that was that could run on multiple operating systems that reduce the friction for that. And this is what we try to do. We try to reduce the friction as much as possible for all the developers. So your IoT devices are always updated with the most. So you can focus basically on deploying new applications and new versions or new releases on your IoT devices. So just really quickly, as I mentioned before, we have a Balena OS, which is a minimal Yocto. It's a Linux operating system based on, it's open source and it's based on Yocto. And why we do an operating system, it's to make as many IoT devices compatible as possible on this operating system. It's open source. You can run it on your devices without paying anything. The only special thing is that it only runs containers. You cannot run anything on the host OS. Okay, so this is how we try to educate as well developers to start using these new toolkits like like Docker containers. And for us, the containers is the Balena engine. Okay, so we got the Docker Mobi project and we just tune it to make it very well, that could work really well on IoT devices for multiple different device types. Finally, just to mention that everything that I'm going to show, of course, it's compatible with Linux and Docker, but as well, we have an open source stack, which is you can run Open Balena, okay, on your server, and it works, or you can run it on Balena Cloud with 10 devices for free. Basically, I'm going to go very fast here, but what we do is we run Balena OS with the Balena engine, and on the top of that, we have a supervisor that checks if there are new releases, and we have the containers there. So what I'm going to show you, so in one click, you can just deploy the main stack on your Balena device or on your Linux device. And basically, along these containers as well, you can run anything else that you need just to add the business logics that you need on your application running along the main stack. Okay. Actually, we also have a marketplace, so you can find the Ming stack here, or you can go to my GitHub account. I'm going to show the URL in a second. Okay. And basically, finally, what you see, it's something like this. This is called Balena Cloud. And you see the service of Grafana, InfluxDB, MQTT, Mosquito, and Node-RED. And we're going to discuss what services are useful to run. One service that we think is very useful to run on IoT devices is one called Wi-Fi Connect, in case that these devices run Wi-Fi. And Wi-Fi Connect, basically what it does is if it doesn't detect any Wi-Fi or any internet connection, brings the single board computer into hotspot mode. So you can connect from your laptop or from a computer or your mobile device and just connect to the new Wi-Fi. So this is as well an open source service that you can run anywhere. So let me show you some examples about Ming, because I talk a lot about the Ming, the Mosquito, InfluxDB, Node-RED, and Grafana. But maybe some of you will ask, okay, what is this? So this is actually running on any device or anything. I'm going to show you a couple of examples, and I have everything here. But first example that I actually blow my mind with the Ming stack was this LoRaWAN network using the Things Industries or Things stack with the Ming stack, actually. In case that you don't know what is a LoRaWAN network, let me just give you a brief introduction. So basically, a LoRa network, it's a radio network that it's low-powered weight area. That means that you can send from microcontroller devices radio packages using this LoRa radio technology that it's managed by Semtech. Tiny packages of data, like in a lot of kilometers around the sensor is located. And these messages need to be captured by a gateway. Okay, this gateway is listening different. I don't want to get very technical on the LoRa. I really love these old LP1 technologies, but and I could talk hours about it. But it's basically a star topology radio technology that allows you to send data from sensors in a very low power mode. So actually, you can have like temperature sensors or these type of sensors that are sending these tiny messages with maybe 2 batteries, and they can last like 5 years. Okay, so you don't need energy, etc. And then you need to have some gateways with internet and, of course, electricity, and that send data to a network server. There are multiple network servers. One of it, there are a lot. There is Chirpstack, Helium, LoRa IoT, etc. But one of it is called the Things Stack, which has a community edition. And what we did on this project, actually, what one of the developers from the Balena community did on this project, and this also works on any Linux with Docker single board computer, is basically made everything that you see here, except the devices part, the gateway, the LoRa network server, and the client application, all together in one device. So you can create your private LoRaWAN network on just with one Raspberry Pi, with just you need the basic station, the packet forwarder on it, and you can have everything private, even offline if you want, and running with a Ming stack as a client application. Let me show you what it means. Well, actually, I have it somewhere. Maybe I can stop. It's this one, if I'm not wrong. Yeah, this is my Pi 4. And basically, it runs basic station, which is the packet forwarder, means that this service, it's in charge of getting the LoRa packages and convert these LoRa packages into IP packages and send them to the LoRa network server. But the LoRa network server, instead of being in the internet, it's local. So usually the stack goes to, well, on the Things industry or the Things network or others as well. The LoRa network server is in the cloud. So you send the data, so the gateway just forwards the data to the cloud. But in this case, it sends the data to this service, which is called Stack, that needs Redis and Postgres. And then we have Wi-Fi Connect, as I mentioned before here, but we have Node-RED, InfluxDB, and Grafana. We don't have here MQTT, because actually the Things stack actually has an MQTT broker. So the Things stack, it's gonna publish MQTT data when you configure it properly. So every time that you get LoRa radio messages, the basic station forward it to the stack service, and this stack service actually decode the radio message and then publish a message on the MQTT from the MQTT broker that it has, and then Node-RED will receive this package and actually store it on InfluxDB and visualize it on Grafana. So you can have your LoRa network server basically, and all the LoRaWAN stack actually in one Raspberry Pi in just one click and a few configurations that are really simple. Yeah, I didn't get into the Things industries. If you know this, the community edition of the Things stack, it's really nice. And for example, in this case, on Node-RED, basically we subscribe to this topic, all the app links from the Things stack, we map the data, and basically we just store it on InfluxDB. And then let's see. Okay, I don't have any Grafana visualizations, but then you can visualize it basically on Grafana. And then something that I'm exploring lately, it's as another example now that I'm getting without time, it's industrial IoT with the Ming stack. Basically, I talk with a lot of community members from the industrial IoT. On Balena Hub, you can find industrial IoT devices. But Node-RED is really good and has a lot of contributions, basically, on translating a lot of legacy industrial IoT or not legacy industrial IoT protocols into MQTT, for example. So it's really easy to get data from Modbus to pull Modbus data, OPC UA, etc. systems, Siemens, etc. From Node-RED. And then basically from a gateway, just make sense of that and publish it on an MQTT. I just made a lot of blog posts lately on the blog.balena.io talking about how to use the Ming stack on an industrial environment and how to use, if you are into the industrial IoT, I'm really happy to talk about this about hours if you want. But basically, I'm using the same architecture that I showed you before. We have this Edge IoT gateway, reading Modbus, OPC UA, or whatever you want. Mosquito MQTT broker helps there to publish the data as well to like a central MQTT broker if needed. And then InfluxDB and Grafana plays this role of having at least a local copy of the data in the edge if this is needed. Yeah, I made a webinar about this, and this is as well public on my GitHub repository. And then I had some ideas as well to share here on the community and maybe create some discussion if we have time about how to extend Ming, because I met a lot of people that was mentioning, okay, I was using Ming, but I didn't know that it has a name, or I was using Min, or someone else was using Mint, or things like that. So it's really nice to see people that come and say, yeah, I was actually using exactly the same stack, but I was not aware that could be a thing and that could help to reduce friction to other developers. So actually that happened to me as well. So actually the LAMP had a lot of different differences. I actually used a LAMP stack, but I remember that I used SHAMP. I also, when I had my first Mac, I tried MAMP. So yeah, it had a lot of different variants. And actually, this was not the only one. Actually, as an evolution of the LAMP, I remember that actually some years after I tried Mean, that was MongoDB, Express, AngularJS, and Node.js, which actually was not exactly the same, but yeah, it helped actually to get into the into the next Web 2 maybe technologies with a new framework. Not sure if anyone tried this. But yeah, I was here just brainstorming myself last week, thinking, okay, what can we do? How can we extend the Ming stack? I don't know. Any idea here on chat, or people is already sleeping with my war stories? Any idea? Yes, no, yes. Okay, I will share some of my ideas. Okay, and I'm looking forward to seeing. Okay, Frederick would love to see Ming evolve into Mings and the S standing for a Sparkplug. Sure, yeah. No, actually, that's a very good point. Yeah, I've been working with the Sparkplug B lately, and actually you can use on Node-RED. There are the Sparkplug nodes that are contributions from Node-RED, so you can actually get Modbus data or whatever data into Node-RED and actually map them into Sparkplug. If you have an MQTT, well, I think you don't need any MQTT. Directly you can do that, and yeah, and actually send with to Sparkplug to an MQTT broker outside. So this is actually doable. I'm working on an example like this. I will ping you once it's done. But yeah, this is doable, straightforward with Node-RED. So some ideas, okay? I like Grafana because it's really good, but some people complain about Grafana because it's really hard to interact with Grafana and then get the data back to Node-RED, for example. Something that I want to start thinking, it's about this Eclipse project called Streamsheets. Not sure if anyone here in the chat has played with it. Please let me know. But I would really like to have to try to have UIs where you can get bidirectional communication, and so you can get data back to Node-RED, for example. And I think Streamsheets can help on this. Not sure if I'm wrong or not. I would like as well to try, but I'm not sure if it's too huge for the Ming stack or for a single board computer, Eclipse Ditto. I don't know anyone here with experience with digital twins with Ditto. But I think it could be a really nice complement where you can get data from different devices and just start creating the digital twin. And meanwhile, you receive the data. Let me know if I'm completely wrong as well. Another interesting story is that the Ming stack works for IoT edge devices, but you can deploy it actually on the cloud if you want. So yeah, it's basically, if you get the Linux with Docker, you can get Balena OS automatically running this, or you can put it on any Docker with Linux, and that will work. Anyone with experience on stream sheets on Dito? Yes, no, in the chat. So I would love to see people start contributing on bringing new ideas. Actually, we have people from the community adding new things like ThingsBoard. We have another developer, actually Alex Lennon, the creator of this concept. I'm not sure he just is the one who told me this concept, but he wants to add traffic on the Ming stack, just to let you know. But happy to learn from the community what else could be useful to have on the Ming stack. This is my GitHub, actually. This is my address. Actually, let me put it here on the chat. Sorry. GitHub.com. Ming, it's simple. I'm happy to get comments there. So if you don't know about Docker, we have Docker Compose for multi-container applications, and you will see all the services there. If I would have time, I would show you how to build it, but I think I'm running out of time, if I'm not wrong. And okay, let's wrap up. And if I have time, I'm happy to answer questions or to show more things. But I think the Ming stack can reduce friction to developers who don't have any clue about IoT, or they do, but they don't want to start from scratch a project. Okay, and instead of investing like a weekend on a project, they can just invest like 1 hour and have everything up and running with open source technologies for free. It's open source and it's free. Even if you use Velena with one device, you will have it for free in one click. I think it's flexible and scalable. Actually, I've seen these on multiple devices on real life, and it works, and it's pretty amazing. It's Frederick mentioned, I want to see Sparkplug. Okay, it's done. Okay, and I think and it's open to anyone to contribute. So I'm explaining this from this Velena point of view, but I'm happy to get it from other points of view of any Linux, so as with containers. And I think it's important to put in the mindset of developers that we need to start using new tools that are available on other on other type of developers like DevOps, WebOps, web developers, etc. We need to start using these technologies on IoT because they are available and they are here for free with a lot of open source projects to run. What else? These are my credentials in case that you need to contact me over Twitter or by email, and I'm happy to answer any question.
Thank you so much, Mark, for this great presentation. Very interactive. Loved the engagement with the audience. So thank you for that. We do have one question in the Ask a Questions. So could you please compare Ming to ThingsBoard?
Oh, that's a very good question. Actually, one of the developers from our community just add ThingsBoard on the top of the Ming stack. Okay, so run the ThingsBoard. I'm not an expert of it. I only run it twice. But I think so. I think Node-RED and so having a system like Node-RED that can get contributions from third parties to have more and more different protocol systems integrated quickly, or even you can type it yourself, can give you more flexibility than just using one specific system. Even if it's open source, then you can run it in the edge for free. And then I'm not aware of the latest on the latest version of ThingsBoard, but I can point to this user who asked this question about this Ming that when I mentioned this Mint was using ThingsBoard instead of Grafana. So I'm happy to point who is asking this question to this repo, which is on the Velena forums.
Yes, no problem. It's actually, it's Robert. So Robert, if you'd like to reach out to Mark, you have his credentials and GitHub if you wanted to get a little bit more information from on that topic. And
feel free to send me an email or a tweet or whatever, or a LinkedIn message or whatever you feel more comfortable with.
Amazing. And now Frederick has a question as well. It says, do you think AI will replace human developers anytime soon? He thinks no, but he's curious about your perspective.
That's a very good. That's a beer discussion, right? So we should all grab a beer and start talking about this.
I'm highly interested in this answer as well. So please, Mark, enlighten us. Tell us what you think.
I think it's really interesting to have agents that can help us to accelerate what we do. The problem is what knowledge do they have, and if what they suggest us is correct or not, right? So if I ask to deploy, I don't know, stream sheets with the Ming stack, and what I get, it's a complete fucked up Docker compose, and I don't do the exercise as developer to learn to read the documentation, etc. That could be a big problem in the near future if developers start trusting blind on AI. But I think they will help a lot on accelerating the development of specific things. Absolutely. I don't know. I don't know. I have maybe to compromise. That will begin a peer discussion, and I don't think. But it's really interesting where it's going. These AI developments that we have seen. I still haven't tried GitHub Copilot, for example, but let's see.
Interesting, but scary for a non-developer, for sure.
But for a non-developer, it's really interesting, actually. You can say, I want a script that does this and that. For example, I've seen some developers from the LoRa community, some beginners that, when you need to decode a LoRa message, you need to play with bits and bytes. So I have seen some examples of ChatGPT helping on building this decoder. So like a non-developer can go to ChatGPT and say, okay, I have this LoRa message with these bits and bytes. Can you help me to decode it? Just copy and paste, and if that works, that's amazing. But if that opens a port that you don't want to open and third parties get access to it, I actually think that I think was Mike's keynote was really interesting about the certificates of code and source code, and that will be really interesting because sorry I'm getting more and more into the question.
That's
but
okay.
I remember these questions about the autonomous car. Now if the autonomous car have an accident or a crash with someone, who is the fault? It's the car manufacturer or the developer who developed wrong the code of the car. And now we will need to say if it's the AI system that helped this developer to program this, and so it will be funny. This goes back to Mike. Absolutely. I really like that keynote, and I will rewatch it and ask more questions to Mike because that was really, really interesting.
Definitely.
What else?
Any
other questions?
Is there anybody else? Anyone else have questions? Mark has full of answers.
No, not full of answers. I don't know if I actually don't know if I answered the question from Frederick, but it's interesting. I think we should do something. I challenge the Eclipse Foundation to do like open the mic for everyone.
That's a great idea. That is actually a really great idea. I'll definitely do a takeaway on that. Well, I just wanted to say thank you again, Mark, for your time, your amazing presentation, and great interaction. Next up, we have at 1:45 Eastern Time, Martha, one of our very own, as well here at the Eclipse Foundation. So we will see you all soon.
Awesome. Thank you very much.
Have a good day. You too. Welcome back, everyone. Joining us now is Martha for her talk on the 5 easy steps for more secure IoT. Martha, over to you.
Hi everyone. Do you think that security is difficult? Some of you probably do. I will say that it depends. If you come to take over an existing system that has been developed without thinking about security from the beginning, and at the same time you want to fix everything at the same time, that is going to be difficult. On the other hand, if you start from scratch, you start with best practices. And a few steps and tips I'm going to share with you today that is not that difficult and integrates well with all other good practices in software development. We are going to explore today my favorite 5 easy steps for securing IoT. But first, who is Martha? I have PhD in telecommunication and was working on network security from the beginning. So networking is my pet. But during the years, I've been working in different projects from different perspectives, for a chip vendor, for device makers. So I have seen examples of different projects, different use cases, different organizations. And currently, I'm helping the Eclipse Foundation improving security of its projects. The experience for today comes from a big number of projects. Linux-based systems, different RTOSes like Zephyr, FreeRTOS, and proprietary RTOSes too, and also one of my recent developments in the Eclipse Oniro project. So we have various examples at different types of operating systems and configurations. Now, when you start looking in your favorite search engine and search information about IoT security challenges, what you are going to see? Different things. But there are some subjects that repeat each other. You get news articles, lists of challenges. The first place is probably about botnets. All those IoT devices that have been owned by malicious people and they are now running botnets and attacking different machines. Then another subject is vulnerabilities in firmware, especially firmware that you cannot change in the device. Then, getting more and more important, insecure networks. Networks not only without encryption, but also networks using protocols that maybe have security options built in, but in different configurations, developers decided to disable those security options. Then another type of security challenge is data privacy. User personal information like locations, their photos, their names, addresses, and all that. And for the case of cameras, all those cameras that everyone can get into and can stream image from, well, basically everywhere. And then missing encryption, devices sending passwords and other data all around the place, all around the local network, without any encryption whatsoever. Those are problems, definitely. But what we have in the middle, we have our developers who get requests for even more features all the time. The time to market that is important to get the project out, but then there is less funding to support the devices that are actually deployed. We are getting more and more complex configurations of networks and different network protocols that are connected together. We have had an example at the previous presentations with different networks all connected together. And then at the end, we have the need for shiny user interfaces. And at the same time, we ask developers to write secure devices. That could be complicated. What is my solution to that? I'm not able to give developers more time to work on security, but I can give you one big suggestion. The security people call one of the security main principles defense in the depth. What it is? You've seen old castles. You have one set of walls, inside you have a second set of walls, and then you have even a third set of walls. Defense in depth is exactly the same thing. Multiple security measures at the same time. If you have one wall that has a hole, there will be a second wall that's going to block the attack. An example, without castles, but with IoTs. In a project, the measures we can use: train developers in writing secure code or writing good code in general. We add mandatory code review. We add tests and test coverage. We secure the default configurations. We write passwords and other elements. We start running applications with lowest permissions possible. We enable hardware protections. For Linux-based device, that's going to be obvious. We have MMUs, we have different security features. For smaller devices, it's not that obvious. You may have an MPU that may not be enabled by default, and you can enable it. And then you have all the hardware mechanisms you can use. And then we have security updates of the product. How does it look like altogether? Just one step from that list is not going to solve the problem. But if you are going to implement all of them together, the risk of a serious issue is going to be way lower. In my presentation today, we are going to talk about such steps that work in multiple projects that you can reuse directly or changing a little bit in your project and put it as one of the defense walls. And then you add a few more, and your security in the project will be way better than at the beginning. How am I going to cover this subject today? For every single suggestion, I'm going to talk about what to do, then why, what do we gain, not always only in security. We may have other gains. And then if you are interested into getting more into details, getting more advanced in that step, a few suggestions about next steps you can take. So let's get started. My first and favorite, removing unneeded dependencies. What do I recommend you to do? Review your package list and configuration options. Package list mostly for Linux-based systems and configuration options for RTOSes. And ask yourself and other developers questions like, do you know which feature of the project requires that options or that package? Was it there by default and we never wondered if we need it? And what breaks when you remove it? A hint, if you remove it, nothing breaks. It means that either you do not have test coverage or you do not need that feature altogether. Reviewing a package list and configuration options allows you to have excellent discoveries. I have had that with Oniro project, looking at one dependency that was bringing like 20 packages of more and asking questions, do we actually need that? And finally realizing after multiple discussions that this is required only when a certain option is activated and we absolutely do not need it. And then all of those dependencies went away. The other typical place to look for or options that you do not need is development options. It's a very classic error for developers to forget disabling development options in a product. For example, in the Octo project, there's debug tweaks option that activates quite many things, including root login by default. And it happens that it gets forgotten. Just you remove it and you get rid of a big number of dependencies. And then if you have a debugger or a compiler in the production image, this is usually a problem. And you can remove a lot of disk space estate by just removing it. And why? Why do we take that work to remove unneeded dependencies? The attack surface, so the code the attacker might try to use against your product, is getting smaller. The most certain code to not contain a vulnerability is the code that you do not have. No code, no vulnerabilities. And then, if you have features that are unused, they are likely not tested at the same time. What it means? There are bugs. You have all interest to remove unneeded dependencies. You gain not only security, small image, be it the RAM, the flash, or disk space. And then, if you are more interested in analyzing your dependencies, have a look at the use of software bill of materials. You can compare different software bill of materials from different versions of the product, from different releases, and look at what changed, what has been added, what has been removed, is it needed or not. You can do quite many interesting things with software bill of materials. Now let's get to the second idea. The second idea is restricting remote access. Our IoT and edge devices, they are connected, so they have remote access. But do we need all kinds of accesses that this device have? A few ideas, what you can do. Make sure the root SSH login is disabled. Yeah, really, it happens in production devices. In OpenSSH is the permit root login option to set to no. And then going further, remove all SSH or even telnet, that happens, login for all users that you do not need. And for most products, you do not need SSH access. You may decide to have a special purpose console with limited commands that you allow the user to have. In this case, that's a and you want to have a console for the user. Then restrict the login from the internet site. When I was starting embedded devices, I remember quite many routers from best providers had the web access available from the internet. Usually with the default password, so it was trivial for attackers to get on the device. And still, there are devices with login
Welcome, West. Thank you so much for joining us today. West will be presenting on his Going Beyond MQTT with Sparkplug. West, over to you.
Thank you. Good afternoon. Good morning, everybody. All right, hopefully everybody can see that. So I'm here to talk a bit about MQTT and mostly Sparkplug today. So just a bit about myself. I work for CirrusLink Solutions. We're a company that was started about 11 years ago now. And we've been doing lots of MQTT-based applications from the start. Our CTO was actually one of the co-inventors of MQTT. I personally joined working with Arlen in 2004 at Archon Control Systems, where we also did lots of MQTT-based applications. Later on, I worked on and was project lead for the Eclipse Cura project, which is an Eclipse-based device management framework, and now also work on and lead the Sparkplug project team, and also the Tahoe project team, which is the implementations of Sparkplug at the Eclipse Foundation. So to get started, obviously we have a lot of history with MQTT, and we've noticed some things recently about sort of the dynamics of the Internet of People and the industrial Internet of Things, and some things that were really lacking in the technology to make the industrial Internet of Things really possible. So a long time ago, in the late 90s, there was the Internet of People. And so with that, there were things like the LAMP stack, which allowed developers to quickly and easily create websites and really connect people to ideas and things. And with that, sort of the backbone of that was HTTP and HTML. So HTTP is a protocol based on TCP that allows data to flow between computers. And HTML was the language that was used to allow things like web browsers to render data and allow web servers the ability to serve that up. So the language needed to be there in order for servers and browsers to talk to each other in a way that made sense and then was able to be easily consumed by people. MQTT has been in the industry for quite a long time at this point. I believe it was 99 that it was invented by Arlen Nipper and Andy Stanford Clark for a project at Phillips 66 for oil pipeline monitoring. And so from day one, it was really designed for SCADA systems, or before the Internet of Things term existed, it sort of was built exactly for that. There has been a lot of adoption over the years. I believe notably it was around 2008 or so that Facebook picked it up for Messenger. I don't actually know if it's still used for Facebook Messenger. But at that point, it really started to explode in terms of usage, even though it had been open from the start. With that, though, MQTT provides a lot of flexibility in terms of how one defines a topic namespace and how one encodes data in the payload. And so as a result, there were lots of disparate solutions that couldn't really talk to each other. And so one of the things that we did at CirrusLink was invent Sparkplug. And so with our expertise and all of the projects that we had done, we took our knowledge and tried to encapsulate a lot of that into what we saw as a language that could be used in conjunction with MQTT to actually allow the industrial Internet of Things to come to fruition. And so just like Andy and Arlen did with MQTT, we really wanted it to become open and something that others could use to actually make that possible. If we'd kept it proprietary at CirrusLink, it was only beneficial to us and wouldn't really help the industrial Internet of Things become a possibility. So just some quick basics about MQTT. I think probably most people here know the basics, but it's a publish subscribe transport protocol where messages are made up of topics and payloads. There is no real standard in terms of what a topic is. There's the hard requirements about what it can contain in terms of ASCII characters and what slashes mean and what hash and plus signs mean. But when starting a project, really, you need to define what your topic namespace is, because at the end of the day, really, you want your MQTT clients to be able to communicate with each other. And so producers of data need to produce it in a way that a consumer of data, which is also just another MQTT client, is capable of consuming it. Likewise, with payloads, they can be large, but there is no requirements within the MQTT specification about what those need to be. And so early on, we created lots of payloads that were XML because that was common in the early 2000s. And we've since moved on to other protocols, binary and JSON. But again, any producer needs to produce data in such a way that a consumer can actually consume it and use it. The effort involved in doing this could always potentially be pretty time consuming. So at the start of a project, you need to define these things, and then you go through the process and then actually implement the application. And then invariably it can lead to potential problems down the road as well. So say additional applications want to come in and consume that data, then they have to do it in a way that fits how that topic namespace and how that payload definition was constructed at the time of the producer. And so even for us, with our experience over time, we found that we wanted to change things. And so it could lead to difficulty in expanding MQTT-based systems over time. So what does MQTT do? So it's a server client environment. There's an MQTT server, and clients make inbound connections to that server, and then they can publish or subscribe on data. So any client is equal in the sense that it can be a producer and or consumer of data. It's also important to note that because it is a client-server relationship, all clients are making an outbound connection to the MQTT server, which we'll talk about in more detail with regard to Sparkplug. Then there are three primary components of a message. There's the topic, the payload, and the quality of service. So the topic is often used for routing of messages. The payload is exactly that. It's an array of bytes that could be encoded in any way that one wants to encode that data. And then the quality of service is a feature around how that message actually gets delivered. And so it's important to note it's actually a contract between the client and the server and not a client to another client. And those qualities of service can be either 0, 1, or 2. And so 0 is at least once, which is also often referred to as fire and forget. Then quality of service 1 is at least once, which means it will get there for sure, but it may get there twice or more. And then QS2 is once and only once, which means it'll get there, but only one time. So MQTT provides the acknowledgements and the handshaking to ensure these different qualities of service. So topics are /delimited strings, and again, are often used sort of as addresses for messages. So those addresses can be where that message came from. It can be where it's going. But there's a lot of flexibility in terms of how you want to use these in any given application. So as a result, with MQTT having been out in the wild for quite some time, there are lots of different ways that people have done this. Payloads, again, are arrays of bytes. There's no schema. It is literally just an array of bytes, and it can represent data in any way that you want, as long as it can be represented as an array of bytes. And quality of service, I already pretty much covered there. All right. So now, why Sparkplug? So MQTT is great, but like I said, it isn't really enough to do anything without further definition. So in terms of a topic namespace, how should that be constructed in a way that makes sense and is consistent across different devices and or consuming applications? And so when starting a brand new MQTT project, it's up to you to define what this topic namespace is. Likewise, for a payload, you need to do the same thing. So you can define it as JSON or XML or some binary encoding. But again, as long as you make it so both clients are able to communicate with each other, then you're in good shape. Just a quick note on payloads. One of the things that we really focused on at CirrusLink and also with the development of Sparkplug was sort of sticking true to the original design concepts of MQTT. Because MQTT was designed for a pipeline system, the communication was over really bad networks. So using VSAT and things that were very expensive and also were not capable of transmitting large amounts of data. So efficiency was really key in the development of Sparkplug, just like it was with MQTT. So that was why we chose Google protobufs for encoding of data. Quality of service, then how do we guarantee the data shows up? And do we really always want to guarantee that data always shows up? So a common example for use of quality of service 2 is something like a banking application. So let's say MQTT were being used in a banking application. You would want a customer who withdrew money to make sure that it was only actually withdrawn from their account one time, certainly not more than one time, and certainly not less than one time. So that's a good use for QoS2, but in our experience in SCADA applications, that's typically not actually ideal. So oftentimes in processes, whether they be on a pipeline or in a manufacturing facility, you want certain things to occur in a sequence of events where if something in that sequence doesn't occur properly, then you want to be able to either roll things back, but certainly not have, say, some event be delivered minutes, hours, or even days later, which could happen if you're using things like QoS 1 or 2. So an example here is, say there's a sequence of events that open and close valves in a certain order. You certainly wouldn't want a QoS 1 or 2 message to get stuck somewhere in the process and end up opening a valve that shouldn't be open later. There are certainly potential safety considerations there. All right, so MQTT is great, but how do we arrange these clients? So again, because Sparkplug was largely designed with SCADA systems in mind, we really didn't ever have the concept of all clients subscribing and producing equally. Instead, we often have a lot of different devices that are out in the field. And again, the field could be along an oil pipeline, that could be in a manufacturing facility, or on vehicles. And then often you have one or more consuming host applications that are receiving all of this data and then doing something interesting with it. So that could be providing it to the cloud for machine learning algorithms. It could be for simply historizing it to make it available to people in the enterprise so they can see information about the efficiency of their processes, things like that. So that would be a host application. Historically, those were SCADA host applications. So they were the things that were really controlling those processes in the OT environment. So then for messaging and picking a topic namespace, there are lots of IoT devices that exist out in the world today, and they'll typically have some sort of device identifier. It could be something like an IP address or a device ID or a MAC address. And then oftentimes what we see is something like a process variable. So it'll just be temperature. But we found that this becomes really cumbersome, especially in an operational environment where you might have a handful of PLCs, which could produce a huge amount of data. So then you have lots of different temperatures, you could have lots of different pressures. And so the namespace gets really heavy really quickly if you have a really simple namespace definition like this. So QoS2, I already covered why there are certain scenarios, especially in operational processes, where you wouldn't want to use QoS2 in all circumstances. And I would argue that it's often not the preferred way to go. And so for that reason, we actually don't use QoS2 in Sparkplug at all. And I'll explain how we can do that here shortly. So as far as schema and format goes, again, there are lots of options here, but we chose Google Protobufs for a few reasons. One, it's really efficient on the wire. And again, originally with MQTT, we wanted to be efficient because we were using expensive, high latency, low bandwidth networks. And so we wanted to stick true to that because it's still being used in many of those same environments. But we also wanted it to be capable of being cross-platform. So even though for our products that we create, they're all based on Java, we knew that there were lots of other small, low-power embedded devices that would need Sparkplug implemented in C, plus other enterprise applications that would need to consume this data. And so obviously Java and C# are often used in those environments. So Google Protobuf provides great tooling to be able to be cross-language. So then security. So there was a common phrase in the SCADA world for a long time that was security through obscurity. And so just because there were complicated protocols that were used, people just couldn't decipher what those bytes were. But obviously that's not good enough anymore, and probably never was. But to a large extent, we have taken the same approach with Sparkplug that was taken with MQTT, and that is that Sparkplug isn't really the owner of the security model. So with MQTT, the decision was made that because MQTT was based on TCP/IP, that there would be evolving security mechanisms around the TCP/IP protocol, which of course has been true. So things like SSL have existed for a long time that have also evolved to be able to support security for any TCP/IP socket. And so Sparkplug is really piggybacking off of that, at least for the time being, in that the actual socket itself is secure through security mechanisms that are supported by TCP. So then, are there potentially other things that we could do to make it more efficient? So we examined that with the creation of Sparkplug as well, and introduced things like aliasing, and in future iterations we plan to introduce payload compression as well. All right, so this is one of the most important concepts of Sparkplug, and that is the notion of an MQTT session. So Sparkplug is built on MQTT, which is built on TCP/IP, which is a stateful protocol. So oftentimes it's not used in that way. So for things like a REST post, you would establish a socket briefly and transmit data potentially in both directions and then close that socket. MQTT is really a protocol that was designed with the idea that you would open that socket and leave it open. And then you would continuously use it to transmit data in both directions. So again, it's outbound originated, which means that the connection can go out to an MQTT server, but once established, then data can flow in both directions. Likewise, MQTT also is bookended by MQTT provides a death certificate. So that is the will message in the MQTT protocol. So at connect time, you can basically say through that connect packet that when the socket is lost, if I as an MQTT client disconnect ungracefully, so if the socket just gets torn down, say the underlying satellite link goes down or the underlying cellular link, then the MQTT server is obligated to deliver that will message to any consuming clients. So in our case, we use that both by host applications as well as by edge nodes, which are the client device applications, to notify the other clients when that session goes down. So we were able to utilize what was in the MQTT protocol for the death, and then we also created the concept of a birth in Sparkplug. So it was something that we had been using for a long time in MQTT projects. I know it had been a concept used in other MQTT projects as well. And so the idea is you establish this session, and once you establish that session, then you can transmit data on an exception basis. So when that data changes, you can publish those change events, but you don't actually have to publish more than that. And that is because that session is established, and anytime that change event occurs, that can be published. But then the consuming application always knows the current state of that data because the state of the MQTT session has been established. So then, how often should we publish data? We don't need to do anything more than when it changes. So in a birth, we actually publish all of the data for all of the tags or metrics that we know about, and then we only publish data when it changes. Then when that socket is lost and the death is delivered, when we reconnect, we have to republish all of our data again. But we don't have to do anything on a polling basis or anything on an interval basis because we have that stateful session established, which allows us to know that we only have to publish data on change. So again, I've already covered why QoS 1 and 2 can be dangerous, but again, also QoS 0 is not really as dangerous in this situation. Really, it's not, because the session is established. Sparkplug also provides the concept of sequence numbers, which allows you to ensure that no data is actually lost. And so, of course, TCP actually does this too. And so as long as that socket remains open and data is flowing, then QoS 0, even though it is fire and forget, we are ensuring that that data is arriving and also arriving in order. So really, the end result of this is that we can provide really fast feedback of change events at the edge into a host application because we're publishing data on change through an established socket, and we're not publishing periodically, and we're not doing any type of polling from any sort of host application. So depending on how fast your data is changing versus how fast you want it, really what ends up happening is you get much faster response times with far fewer bytes. All right, so this sort of goes through the flow of the three different major components of a Sparkplug application. So there's the MQTT server, which again is just any type of vanilla MQTT server, as long as it's 311 compliant. And it actually doesn't even quite have to be that, because we don't have a requirement for things like QoS 2 level messages. Then you also have a primary host application or a host application, and then you have an edge node. And typically you would have many edge nodes in a Sparkplug infrastructure. So the idea of this state management is that the edge node connects to that MQTT server, and what it does is it looks for the presence of a primary host application. And so it does that by subscribing on a topic, which is defined in the Sparkplug specification. And it's the responsibility of the primary host application to basically declare when it is online or when it's offline. And again, if it were to lose connection ungracefully with the MQTT server on behalf of that host application will declare that host application offline. And so the edge node makes this connection, looks to see that that host application is there. And this is sort of a key concept of Sparkplug, in that really what Sparkplug is doing is creating a contract between the consuming application and itself. So it's a contract between two MQTT clients rather than just between an MQTT server and a single MQTT client. And so it looks to see, the edge node looks to see if that host application is there. And if it is, then it will publish its birth certificate declaring all of the information that it knows about. And then it is now entered that stateful session. And so it, from that point forward, until it loses connection, can publish data only when it changes at the edge. So then there are multiple ways that this whole state can be reset. So if the edge node, for whatever reason, loses connection, it will attempt then, after it does so, to reconnect to the network and reconnect to the server, and then again check to make sure that host application is online. If it's not, then it is obligated to disconnect and then connect to a new MQTT server if there's one available in the network. If not, reconnect to the same one, and again, just continually check until that host application is online. So this is where things like history come into play as well. During this time when these change events are occurring at the edge, they're not obviously being delivered to the host application. And so because it knows it's not connected, and also because it knows that host application is not present and listening, it can store that data in a buffer. And then once that connection is reestablished, then deliver that to the consuming host application. And so this is different than something like a retain message, right? So in MQTT, there's the concept of a retain message, which allows the MQTT server to retain a single message on a single topic. But because we're using the concept of this stateful connection between these two clients, the edge node then can actually store a whole sequence of events for the same tag or the same metric until that connection is reestablished. All right, so some details about the Sparkplug namespace. So this is the form of the topic that we use. So really what we wanted to do was to not include specific tag or metric data in the topic, but rather provide sort of an address for the edge node and potentially the device that it was coming from. So again, there's a lot of history in terms of how we came up with this, but oftentimes we found that there was the need for a group ID of some sort. So that could be something like a region. In initial use cases, it was a specific oil pipeline. It could be a specific manufacturing facility, or really anything you want that would logically group some edge nodes together. Then the message type is really around some of the more intricate workings of Sparkplug in terms of what messages are going where and what type of message they are and what's potentially encoded in them, which I won't get into detail here, but there's lots of info out there and in the spec, of course. Then there's an edge node ID, which was always meant to represent a logical or a physical edge node. So this was typically some sort of smart edge device that was aggregating data from one or more devices. And so those devices represented by a device ID could be something like a PLC or an individual sensor or actuator, or even some logical grouping of data, which is certainly how we use it in many of our own applications. So the namespace, the first token was really meant to define sort of a version of the Sparkplug topic namespace. So we knew we probably wouldn't get everything right on our first attempt, and obviously we didn't. What was largely popularized and is mostly available today is Sparkplug B, and of course there was a Sparkplug A, which we don't talk about anymore. But between those two versions, we were able to change a lot about the payload encoding and make some significant improvements there. And so just by knowing that initial token, you can then sort of determine what your encoding mechanism is for that payload and potentially what comes after that token in the topic namespace as well. So the group ID I already covered, along with the edge and the device IDs. But it's also important to note those are conceptually how we defined them, but they don't necessarily have to be used in exactly that way. At the end of the day, they are just MQTT topic tokens and can really be used in any way that makes sense for a given application. The message type, so I list all of them there that are available today. And so the birth and the death, I already covered those. So those are defining the start and the end of this stateful session. Then there are data messages, which are always flowing from edge nodes up to the host application. So these are those change events we talked about. Then there are command messages, which are messages that go down to an edge node to do things like write to outputs, to potentially send control messages to an edge node, like to tell it to reboot, or to send firmware updates or all sorts of other things. And then the state messages are published by the host application to denote its on or offline state. So the payload definition I'll cover here quickly. It's based on Google protocol buffers. There is a schema. It's also available in the Tahoe Eclipse GitHub repo and in the specification, of course. So this is where we defined all of the constructs of things like what a message is, or sorry, a metric, which is really a representation of tag data. So at its most fundamental level, it contains a value, a timestamp, and a quality, and a data type. And so these are then used as those discrete process variables, which are used to represent data at the edge. We have lots of other different data types, and also very importantly, especially in consuming IT-based applications, we have template support, which allows you to create user-defined types that represent things like models. So you can do some modeling at the edge, which then becomes the source of truth for what is actually at your edge location. Then there are other sort of tangential things around like aliasing for efficiency. It is extendable. We also have support for historical data and how that's flagged within the payload for any given metric. And we also wanted it to be easily convertible to JSON. So we didn't actually want to send JSON on the wire, but we did want it to be viewed in that way through tooling to make human lives easier in terms of figuring out what's going on when things are going wrong. So again, another huge concept of Sparkplug was the concept of the edge being the source of truth and dynamic discovery of data. So what we're able to do with Sparkplug is allow that smart edge gateway to aggregate data at the edge from these devices that may be speaking very complicated protocols, or depending on your level of expertise, maybe not so complicated. But to a newcomer, something like Modbus can be a little bit daunting, and that you're looking at a Modbus address and then you see a value, but you really don't have any context around that data. So at the end of the day, it represents something in the real world. It could be a temperature, it could be a pressure, and of course, if it is, it has some engineering units, and it may be scaled or it may not. And so really what we wanted to do was to allow users to define all of this context and metadata around that value and be able to publish it using Sparkplug and allow any downstream applications to be able to consume it and know what that means without even knowing that it ever did come from a Modbus based device, because a consuming IT application doesn't care. It cares what the pressure is and what its units are, and those more real world things. Right. So, again, really what we were trying to do is provide context and a standard for modeling operational data. And so first we define an OT-centric topic namespace. And so this really gives us the ability to know where data is coming from, but not necessarily what the data actually is. Also, we can define at the edge the models and assets, so the models and instances of those instances of things at the edge. And so Sparkplug allows that through the template concept, which can then also in turn be more easily consumed by IT applications. So we have other host applications that allow it to be consumed by things like Azure ADT, and also AWS Sitewise, and also now Snowflake. So using this concept of models, we can easily bring those into cloud environments, and there's no additional work that needs to go into contextualizing that data in the cloud. So the other thing, which was a bit more obvious, and that was creating some context around process variables. So those individual discrete IO points, we can easily create context around those that can be done again in one place at the edge, and any consuming applications will then know what those are just by seeing a birth and getting all of that metadata. Again, a huge one, and this is one that was a bit unique to Sparkplug at the time that we released it, and that most IoT applications that were using MQTT would do things like publish data on a periodic basis. And so every 5 minutes it would say, okay, my pressure is 100. And then 5 minutes later it'd say its pressure is 100 again. And it was redundant and expensive, and also you could only see it every 5 minutes in that particular example. And what if it spiked to 1,000 in between that time? You would never know it. And so because of Sparkplug's use of state management, we can not only reduce the redundancy, but we can also ensure that we get that data that may have been missed in some sort of periodic sending basis. And again, Sparkplug becomes the single source of truth for the data as it exists at the edge. All right, so Sparkplug actually took off a bit more quickly than I thought it might. But I think it goes to mine and Arlen's and Chad's experience when we created it with all of the MQTT applications that we've created. And so really the idea is there's all of this OT data that is being stranded at the operational side of the business, and there wasn't a good way to get it out. And so by using new tools that exist today that can convert all of this OT data into something like Sparkplug, it then immediately becomes consumable by IT applications. And this has proven pretty powerful and is being picked up by the industry. So again, just sort of to show a picture of all of this OT data, and you have all of these different native protocols, and using a smart edge gateway of some sort, then you can use those proprietary protocols or legacy protocols to get that data out into that edge node, and then use Sparkplug to push it into that host application on the left side, and all of that data immediately becomes available to IT applications, which can streamline businesses. So this is just a chart of Sparkplug by industry. So this is specifically a cross-section of CirrusLink sales, and obviously we're heavily involved in Sparkplug sales. And so if you would have looked at this a decade ago, the large majority of this would have been oil and gas. And while Sparkplug didn't exist then, there was some similar concepts that were used here. But since the release of Sparkplug, we've seen this grow significantly in other industry verticals. So we obviously have a significant portion of Sparkplug usage in manufacturing and transportation. And I think this is really cool to see, and that I feel like Sparkplug is actually, as we sort of envisioned it, and it being useful to lots of different industries because of its efficiency and simplicity. So just a quick discussion about Sparkplug 4. So these are some of the things that we're currently talking about in the Sparkplug working group today. So Sparkplug 3, which is the current version, is about to become a global standard through ISO IEC, but we're already looking forward to the next version. So just like with Sparkplug A, we assume there would be a Sparkplug B, and we also now expect there to be a Sparkplug C. And so these are some of the things that we're talking about, and there will be a release plan which will hopefully be ratified by the Sparkplug Specification Committee in June, and then we'll get to work on this new version. Conceptually, one of the things that we wanted to be very careful about was to not do frequent iterative updates to Sparkplug. So Sparkplug is now a cross-vendor, cross-platform, cross-industry standard. And with that, we don't want to have frequent disruptions, and that we don't want to have lots of little releases where little things get broken over and over and over again. So what we're trying to do with Sparkplug 4 is look at all of the major changes that we want to incorporate and spend the time and effort to get everything in, and then have a new release, which will become the next version of Sparkplug. So how to get started. Here is a list of resources. So there's the Sparkplug project itself. There are also both of the GitHub repos. The Sparkplug specification is at that second link there, and also the TCK, which is a tool for self-validation of Sparkplug-based products. If you create your own, you can use the TCK to make sure that it actually does the right thing with regard to Sparkplug compliance. There's the Tahoe project, which is a set of compatible implementations, which are always a work in progress. Also, if anybody is specifically not a Java developer, and that's not that we wouldn't take more Java developers, anybody with interest in other languages, we could certainly use more help there if anybody would like to contribute. There's also the Slack channels and the mailing lists. Then also how to validate and become a member. So if you would like to use the Sparkplug logo and the Sparkplug trademark, these are the steps that you need to take in order to be able to do so. So download, run, pass the TCK, become a member. then sign the agreement and file a get listed request, pass the TCK, and then you can be a Sparkplug compatible product listed on the compatibility page. All right. Thank you, everybody, for listening to some history and context on Sparkplug.
Amazing. Thank you so much, Wes, for this great presentation. We do have a question in the Ask a Questions tab from Frédéric Desbiens. Will I be able to run Sparkplug 3 and Sparkplug 4 on the same broker?
Certainly. So because of the topic namespace token, the first one, they will be compatible to live within the same MQTT infrastructure. Of course, producers and consumers of data, so those edge nodes and the host applications would also need to support both, or depending, you could have a host application that supported both and edge nodes that were producing in Sparkplug 3 and 4.
Okay, perfect. And now we have another question. It's what about MQTT, SN, and Sparkplug?
So we have not done anything for MQTT SN with Sparkplug. I do know that it's been brought up by some others. I think it'd be interesting to look at, certainly, but it's not something that we have pursued today.
Okay, so I think that's it for questions. Thank you again. This concludes day one of our virtual IoT and Edge Days. Thank you everyone for joining us today, and we look forward to seeing you tomorrow morning at 10:30 a.m. Eastern Standard Time. Thank you everyone. Take care.